You are listening to the JavaScript journey, from beginner's code to web development mastery. Like and subscribe to keep up to date on our latest audiobooks. The JavaScript journey, from beginner's code to web development mastery. Chapter 1, Welcome to the JavaScript universe. Imagine the internet as a bustling city. You've got buildings, web pages, roads connecting them, links, and beautiful landscaping, visual design. But what makes this city truly come alive? What allows the traffic lights to change, the elevators to move, and the interactive displays in public squares to respond to your touch? That's where JavaScript comes in. JavaScript is the programming language that breathes life into the static world of the web. While the structure of a web page, its headings, paragraphs, and images, is laid out by HTML, and its visual appearance, colors, fonts, and layout are styled by CSS, JavaScript is the dynamic force. It handles all the interactive elements, responding when you click a button, displaying a pop-up menu when you hover over an item, animating elements on the screen, fetching new information from a server without reloading the entire page, validating forms before you submit them. Think of it using a simple analogy. If HTML is the skeleton of a person, the structure, and CSS is the skin and clothes, the appearance, then JavaScript is the nervous system and muscles that allow the person to move, react, and interact with the world around them. Not Java. Before we go any further, let's clear up one very common misconception. JavaScript is not Java. Despite sharing the Java prefix, they are two entirely separate programming languages developed independently, with different purposes and design philosophies. It's like comparing a car to a carpet. The names sound somewhat similar, but their functions and origins are completely different. JavaScript was originally given its name for marketing reasons, leveraging the popularity of Java at the time. So remember, they are distinct. Where does JavaScript run? JavaScript's primary home has always been the web browser. Every modern web browser, Chrome, Firefox, Edge, Safari, has a specialized JavaScript engine built into it. This engine is responsible for reading your JavaScript code and executing it, turning your instructions into actions on the web page. For example, Google Chrome uses the V8 engine, which is renowned for its speed. However, JavaScript's utility has grown far beyond the browser. Thanks to innovations like Node.js, you can now run JavaScript code on servers, meaning the same language you use to build the interactive front end of a website can also power its back-end logic and databases. This full-stack capability makes JavaScript incredibly powerful and sought after. You can even use JavaScript to build desktop applications, using tools like Electron and mobile apps, with frameworks like React Native. For this book, we'll primarily focus on JavaScript in the browser, but it's worth knowing how versatile the language truly is. A brief history of a dynamic language. JavaScript was created in just 10 days in 1995 by Brendan Eich, a programmer at Netscape Communications. It was initially called LiveScript, but was quickly renamed JavaScript. The language wasn't perfect, but its ability to add interactivity to static web pages made it an instant hit. As JavaScript's popularity grew, so did the need for standardization. Different browsers implemented the language in slightly different ways, leading to compatibility issues. To address this, an international standard was created by ECMA International, leading to the creation of ECMAScript. JavaScript is essentially Netscape's, and now everyone else's, implementation of the ECMAScript standard. When you hear about E6, ES 2015, or ES Next, these refer to different versions of the ECMAScript standard, bringing exciting new features to the language over the years. The ES 6, or ECMAScript 2015, update was particularly revolutionary, introducing many modern features we'll explore. Why learn JavaScript now? The web is ubiquitous, and JavaScript powers almost every corner of it. Learning JavaScript means high demand. JavaScript developers are consistently among the most sought-after professionals in the tech industry. Versatility. As mentioned, you can build full-stack web applications, mobile apps, desktop apps, and even command-line tools. Vast ecosystem. A massive community, countless libraries, frameworks like React, Angular, Vue, and tools exist to help you build almost anything imaginable. Accessibility. JavaScript runs everywhere, and there are abundant free resources to help you learn. You've made an excellent choice to embark on this journey. Setting up your development environment. To write and run JavaScript, you don't need much, just two key tools. A code editor. This is where you'll write your JavaScript code. While you could use a simple text editor, a dedicated code editor provides features like syntax highlighting, auto-completion, and integrated terminals that make coding much easier and more efficient. Recommendation: Visual Studio Code, VS Code. It's free, open source, runs on all major operating systems, and is incredibly popular among web developers. You can download it from code.visualstudio.com. Once installed, you'll find it an indispensable tool. A web browser with developer tools. You already have one installed on your computer. We'll use your browser's built-in developer tools, often called dev tools, to run and debug our JavaScript code. Recommendation: Google Chrome or Mozilla Firefox. Both have excellent developer tools. How to open dev tools: right-click anywhere on a web page and select Inspect or Inspect Element. Press F12 on Windows Linux, or Command+Option+I on macOS. Within the dev tools, you'll primarily be using the Console tab. This is where JavaScript error messages appear, and more importantly, where we can print output from our code for debugging. Your first JavaScript. Hello, console. Let's write our very first line of JavaScript. Open your preferred web browser. Chrome or Firefox are excellent choices. Open the developer tools using F12 or right-click Inspect. Navigate to the Console tab. You should see a prompt, often indicated by a right arrow symbol. This is known as the JavaScript console, where you can type and execute JavaScript code directly. Type the following precisely. Console log hello JavaScript journey. Make sure to include the single quotes around the phrase and the parenthesis, and importantly, the semicolon at the end. After typing, press enter. What happened? You should see hello JavaScript journey printed right back in the console. Congratulations! You've just written and executed your first piece of JavaScript code. The command console log is incredibly useful. It's your window into what your code is doing behind the scenes. Throughout this book, we'll use console log frequently to display values, check logical steps, and verify that our code is working as expected. Understanding console log. Console log is a function. In programming, a function is a block of organized, reusable code that performs a single related action. We'll dive deep into functions in a later chapter, but for now, think of console log as a special command that tells the browser's console to display whatever you put inside its parentheses. In our example, hello JavaScript journey is a string of text. Strings are one of the fundamental types of data in JavaScript, used to represent any sequence of characters. Embedding JavaScript in HTML. Typing directly into the console is great for quick tests, but for building actual web pages, you'll need to embed your JavaScript code within your HTML files. There are two main ways to do this. Internal JavaScript, placing your JavaScript code directly within script tags inside your HTML file. External JavaScript, linking a separate JS file to your HTML. This is the preferred method for larger projects. Let's create a simple HTML file to demonstrate both. Example, internal JavaScript. Open VS Code or your chosen code editor. Create a new file and save it as index.html. Add the following basic HTML structure. doctyp HTML. HTML lang equals n. Head, meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Initial scale equals 1.0. Title my first JavaScript page title. Style, body font family. Sans serif text align. Center margin top, 50px. Style, head, body, h1 welcome /h1. Pay this is a simple HTML page p. Our internal JavaScript goes here. Script, console log. This message is from internal JavaScript. Let's make the page more dynamic. First, select the heading. The document object represents your entire web page. Query selector finds the first element that matches the given CSS selector. Const heading element equals document query selector, h1. Now change its text content. If heading element, Always good to check if element exists. Heading element text content equals hello from JavaScript. Script, body, HTML. Save index.html and then open it in your web browser. You can usually do this by right-clicking the file in your File Explorer and choosing Open With, and then your browser. You'll immediately notice two things. The H1 heading on the page initially said Welcome, but now says Hello from JavaScript. If you open your browser's console, you'll see this message is from internal JavaScript, printed there. This simple example demonstrates JavaScript's power to manipulate the document object model DOM. The DOM is a programming interface for web documents. It represents the page as nodes and objects. When JavaScript changes the DOM, it effectively changes what the user sees on the page. We'll cover the DOM in much more detail in Chapter 6. Example: external JavaScript, the preferred method. For most projects, you'll want to keep your JavaScript in separate files. This practice, known as separation of concerns, makes your code more organized, easier to maintain, and more efficient. Browsers can cache external script files. Let's modify our previous example. In VS Code, create a new file named script.js in the same folder as your index.html file. Move the JavaScript code from the script tags in index.html into script.js. So script.js should now contain console log. This message is from external JavaScript. Const heading element equals document query selector, H1. If heading element text content equals hello from an external file. Now modify your index.html to link to this external file. Remove the internal script tags and replace them with a single script tag that uses the src, short for source attribute. Diositoip HTML. HTML lang equals n. Head. Meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Initial scale equals 1.0. Title my first JavaScript page title. Style. Body font family. Sans serif text align. Center margin top 50px. Style. Head. Body. H1 welcome /H1. Pay this is a simple HTML page p. Our external JavaScript linked here. Script src equals script.js/script. Body, HTML. Save both files. If you refresh index.html in your browser, you'll see the heading change to hello from an external file, and the new message in your console, confirming that the external JavaScript file is successfully loaded and executed. Where to place your script tags? Performance matters. You might notice that in our examples, the script tag is placed just before the closing body tag. This is a common and often recommended practice, especially for script files that manipulate the DOM. Here's why: HTML parsing. When a browser loads an HTML page, it parses the HTML from top to bottom. If it encounters a script tag in the head section, it will stop parsing the HTML, download the JavaScript file. If external, execute it, and only then resume parsing the rest of the HTML. Blocking behavior. If your JavaScript file is large or takes time to execute, placing it in the head can block the rendering of your page, making it appear blank or slow to the user. DOM access. If your JavaScript tries to access or modify HTML elements that haven't been parsed yet, because the script ran before them, it will cause errors. Placing the script at the end of the body ensures that all HTML elements are available in the DOM when the JavaScript attempts to interact with them. The defer and async attributes. Modern HTML offers attributes for the script tag that provide more sophisticated control over script loading and execution, allowing scripts to be placed in the head without blocking page rendering. Defer, how it works. The browser downloads the script file asynchronously in the background while continuing to parse the HTML. However, the script is executed only after the HTML parsing is complete, and crucially, in the order they appear in the HTML. When to use? Ideal for scripts that depend on the DOM being fully parsed, like our script.js example, where we change the H1 element. Script src equals script.js defer script. Async, how it works. The browser downloads the script file asynchronously in the background while continuing to parse the HTML. The script is then executed as soon as it's downloaded, potentially before HTML parsing is complete. The order of execution for multiple async scripts is not guaranteed. When to use? Best for independent scripts that don't rely on the DOM or other scripts being executed first, such as analytics scripts or third-party libraries. If you have multiple async scripts, they might not run in the order you list them. Script src equals analytics.js async script. For now, placing your script tag just before the closing body tag is a perfectly good and simple practice. As you get more advanced, you can explore defer and async for optimized performance. Introduction to comments. As your JavaScript code becomes more complex, you'll need ways to explain what specific parts of your code do, why you made certain decisions, or to temporarily disable parts of your code for testing. This is where comments come in handy. Comments are ignored by the JavaScript engine. They are purely for human readers of the code. There are two types of comments in JavaScript. Single-line comments. Start with 2 forward slashes. Everything from the slashes to the end of the line is a comment. This is a single-line comment. Const message, hello world. This comment explains the purpose of the line. Multi-line comments, or block comments, start with slash and end with. Everything between these markers is a comment, even across multiple lines. This is a multi-line comment. It can span several lines, and is useful for longer explanations or temporarily disabling blocks of code. Const year equals 2024. Why use comments? Clarity. Explain complex logic or obscure parts of your code. Documentation. Provide context for future you or for other developers working on your code. Debugging. Temporarily comment out lines or blocks of code to see if they are causing issues without deleting them. Use comments wisely. Well-written, self-explanatory code is often preferred over overly commented code, but comments are invaluable for the trickier parts. What's next? In this chapter, you've taken your first steps into the JavaScript universe. You now understand what JavaScript is, where it runs, how to set up your basic environment, and how to execute your very first commands. You've also seen how to integrate JavaScript with HTML and the importance of script placement. In the next chapter, we'll dive deeper into the core building blocks of JavaScript, how to store information using variables, the different types of data JavaScript can handle, and how to perform operations on that data using operators. Get ready to start building. Chapter 2, the building blocks. Variables, data types, and operators. In the previous chapter, we took our first steps into the JavaScript universe, learning what it is and how to run simple commands. Now, it's time to delve into the fundamental elements that allow us to store information, make sense of it, and manipulate it. These are the absolute bedrock of any programming language: variables, data types, and operators. Think of your computer program as a chef cooking a meal. Variables are like the labeled containers in the pantry. They hold ingredients data for later use. Data types are the different kinds of ingredients: flour, sugar, salt, water. Each has unique properties and uses. Operators are the tools and actions the chef performs: mix, chop, heat, combine. They manipulate the ingredients to create something new. Let's begin by understanding how we store our ingredients. What are variables? At its core, a variable is a named storage location that holds a value. In everyday life, we use variables all the time without realizing it. When you say, "My age is 30," the temperature outside is 25 degrees Celsius, or "My name is Alice," you're implicitly using variables to store pieces of information. In programming, variables allow us to store data, keep track of values that our program needs to use. Reuse data, refer to a piece of data by its name instead of repeating the value. Change data. Update values as a program executes, e.g., a game score increasing. Make code readable. Give meaningful names to values, making your code easier to understand. Declaring variables. Let and const. In modern JavaScript, there are two primary keywords for declaring variables: let and const. You'll encounter an older one, var, but let and const are generally preferred due to their clearer and more predictable behavior. Let for values that can chain. The let keyword is used when you expect the variable's value to change over time. Syntax. Let variable name equals value. Example: imagine we want to store a user score in a game. Let player score equals 0, declare a variable named player score and initialize it with the value 0. Console log player score, output 0. Player score equals 100. Now reassign a new value to player score. Console log player score, output 100. Let username equals Alice, declares a variable to hold a name. Console log username, output Alice. Username equals Bob, you can change the name later. Console log username, output Bob. Const for values that remain constant. The const, short for constant, keyword is used for values that should not be reassigned after they are initially set. Once a const variable is given a value, you cannot change the variable to point to a different value. Syntax: const variable name equals value. Example: pi is a mathematical constant that never changes. Const pi equals 3.14159. Declare a constant named pi. Console log pi, output 3.14159. Pi equals 3.14. If you try to do this, JavaScript will give you an error. Type error, assignment to constant variable. Const app name, my awesome app. App name equals new app name. This would also cause an error. Important nuance with const and objects arrays. While const prevents reassignment of the variable itself, it's important to understand that for complex data types like objects and arrays, which we'll discuss soon, const only means the reference to the object array cannot be changed. The contents of the object or array can still be modified. Example: const user equals name, Alice, age 30, user is a constant reference to this object. Console log user, output, name, Alice, age 30, user age equals 31, you can change properties within the object. Console log user, output, name, Alice, age 31. User equals name, Bob, age 25. This operation would cause an error because you're trying to reassign user itself. This is a common point of confusion, but we'll reinforce it when we discuss objects and arrays in more detail. For now, remember const prevents reassigning the variable name to a different value. Var, the legacy keyword brief context. You might still encounter var in older codebases. Before let and const were introduced in EASE 6, ECMAScript 2015, var was the only way to declare variables. Var has more permissive behavior, particularly regarding scoping and hoisting, which can lead to unexpected results and bugs. We will explain scoping in a later chapter, but for now, generally prefer let and const for new code. Variable naming conventions and best practices. Choosing clear, descriptive names for your variables is crucial for writing readable and maintainable code. Meaningful names. Avoid single-letter variable names like X or unless they are clearly loop counters. Instead, use names like total amount, username is valid email. Camel case. This is the standard convention in JavaScript. The first word is lowercase, and subsequent words start with an uppercase letter. First name, number of students is logged in. Case sensitive. My variable is different from my variable. Reserved words. You cannot use JavaScript's reserved keywords, like let, const, function, if, for, as variable names. Start with letters, or variable names must begin with a letter, an underscore, or a $sign. They cannot start with a number. Good examples: customer name, product price, items in cart, private value element. Bad examples: first item, var, my variable, hyphens imply subtraction. Data types. The kinds of information JavaScript understands. Just like a chef works with different types of ingredients, solids, liquids, spices, JavaScript needs to know what kind of data it's dealing with. Every value in JavaScript has a specific data type. Understanding these types is fundamental because different types behave differently with operators and functions. JavaScript has several built-in data types broadly categorized into primitives and objects. Primitive data types, these represent single, simple values. String represents textual data. You enclose strings in single quotes or double quotes. Let greeting equals hello world. Let username equals Jane Doe. Let singleChar equals A. We'll learn about a fancier way to create strings using backticks in a later chapter. Number represents both integer and floating point decimal numbers. Let age equals 30. A integer. Let price equals 19.99. Floating point. Let temperature equals negative number. JavaScript also has special numeric values. Infinity represents mathematical infinity, e.g., 1/0. Infinity represents negative infinity, e.g., -1/0. None, not a number, represents a value that is not a legal number, e.g., hello/2. None is peculiar because none equals none is false. It's never equal to anything, not even itself. Boolean represents a logical entity and can only have two values, true or false. Booleans are essential for making decisions in your code. Let is logged in equals true, let is admin equals false. Undefined represents a variable that has been declared but has not yet been assigned a value. Let firstName declared but no value assigned, so it's undefined. Console log firstName, output undefined. Null represents the intentional absence of any object value. It's a special assignment value. Think of it as nothing or empty. Let selected user equals null, explicitly set to nothing. Historical quirk: if you use typeof null, JavaScript will report object. This is a legacy bug in the language that has stuck around for compatibility reasons. Don't be fooled, null is a primitive value. Symbol is6 represents a unique and immutable value, used primarily for unique object property keys. We'll touch on this briefly in a later chapter, not commonly used by beginners. Bigint is 2020 represents integers with arbitrary precision, larger than standard number can safely represent. Also less common for beginners. Non-primitive data type, object. While primitive types hold simple values, an object is a more complex data type used to store collections of data and more complex entities. Objects are fundamental to JavaScript as almost everything in JavaScript is an object or behaves like one. Object, plain object, an unordered collection of key-value pairs. Keys are strings or symbols, and values can be any data type, including other objects or functions. Let user profile equals name, Alice, age, 30, is student, false, is array, an ordered collection of values, index starting from 0. Arrays are technically a special kind of object. Let colors equals red, green, blue, let numbers equals 10, 20, 30, 40, function. A block of reusable code that performs a specific task. Functions are also a type of object in JavaScript. Functions say hello. Console log, hello. We will dedicate an entire chapter to functions. Checking data types with typeof. The typeof operator is a handy way to determine the data type of a variable or a value. Console log typeof hello, output, string. Console log typeof 123, output, number. Console log typeof true, output, boolean. Console log typeof undefined, output, undefined. Console log typeof null, output. Object, remember the quirk. Console log typeof name, Bob, output, object. Console log typeof apple, banana, output. Object, arrays or objects. Console log typeof console log, output. Function, type coercion. JavaScript's flexible, sometimes confusing conversions. JavaScript is a weakly typed or loosely typed language. This means it can implicitly convert values from one data type to another during operations. This is called type coercion. While sometimes convenient, it can also lead to unexpected results if you're not careful. Implicit coercion, automatic, to number. Mathematical operations often try to convert operands to numbers. Console log 5.2, output, 10 string 5 is coerced to number 5. Console log 10.2, output 5. Console log hello2, output. None cannot convert hello to a number. To string, the plus operator when used with at least one string performs string concatenation. Console log hello plus world, output, hello world. Console log age, plus 30, output, age 30, number 30 coerced to string 30. Console log 10 plus apples, output, 10 apples. Notice the order matters with plus. Console log 5 plus apples, output 10 apples. 5 plus 5 first, then string concat. Console log apples plus 5, output, apples 55, string concat takes over. To Boolean, values are coerced to true or false in logical contexts, like if statements. Falsy values coerced to false, false 0, Empty string, null, undefined, none, truthy values coerce to true, all other values. Explicit coercion, manual conversion. It's often safer and clearer to explicitly convert types when you need to. To number, let string num equals 42, let num equals number string num. Converts 42 to 42. Console logs typeof num, output, number. Let parsed int parse int, 123 ABC. Parses as far as it can, result 123. Let parsed float equals parse float, 3.14 pi. Parses as far as it can, result 3.14. To string, let num to string equals string, 123. Converts 123 to 123. Let bool to string equals true to string, converts true to true. To boolean, let to boolean equals boolean 0, converts 0 to false. Let to boolean 2 equals boolean, hello, converts hello to true. Operators, performing actions on data. Operators are symbols or keywords that tell JavaScript to perform a specific operation on one or more values, called operands. Just as a chef uses various tools for different actions, programmers use operators to manipulate data. Assignment operators, used to assign values to variables. Equals assignment. Assigns the value on the right to the variable on the left. Let x equals 10, let y equals x. Y is now 10. Compound assignment. A shorthand for performing an operation and then assigning the result. Plus equals add and assign, x plus equals 5, is equivalent to x equals x plus 5. Equals subtract and assign, x equals 3, is equivalent to x equals x3. Equals multiply and assign, x equals 2, is equivalent to x equals x2. Divide and assign, x slash equals 4, is equivalent to x equals x slash 4. Percent equals modulo and assign, x percent equals 3, is equivalent to x equals x percent 3. Equals exponentiation and assign, x equals 2, is equivalent to x equals x asterisk 2. Example, let score equals 50, score plus equals 10. Score is now 60. Score equals 2, score is now 120. Arithmetic operators perform mathematical calculations. Addition, subtraction, multiplication, slash division, percent modulo remainder, returns the remainder of a division, useful for checking if a number is even odd or if one number is a factor of another. Console log 10% 3, output 1 10 divided by 3 is 3, with a remainder of 1. Console log 4% 2, output 0 4 is an even number. Exponentiation raises the first operand to the power of the second operand. Console log 2 3, output 8 means 2 2 2. Comparison operators compare two values and return a Boolean true or false result. Loose equality. Compares values after performing type coercion if types are different. Console log 5 equals 5. Output, true, number 5 is coerced to string 5. Console log 0 equals false. Output, true. This operator is often a source of bugs. It's generally recommended to avoid it. Strict equality. Compares values and data types without performing type coercion. This is the preferred comparison operator in JavaScript. Console log 5 equals 5. Output, false values are same, but types are different. Console log 0 equals false. Output, false, equals loose inequality, returns true if values are not equal after coercion. Strict inequality, returns true if values or types are not equal, preferred. Greater than, less than, equals greater than or equal to. Less or equal, less than or equal to. Example, let age equals 20. Console log age equals 18. Output, true. Console log cat equals dog. Output, false. Logical operators, used to combine or modify Boolean values. And an and returns true if both operands are true. Console log true and untrue. Output, true. Console log true and false. Output, false. It short circuits. If the first operand is false, it doesn't even evaluate the second. OR returns true if at least one operand is true. Console log true false. Output, true. Console log false false. Output, false. It short circuits. If the first operand is true, it doesn't evaluate the second. Not inverts the Boolean value of the operand. Console log, true, output. False, console log, false, output, true. Example, checking if a user is both logged in and an administrator. Let is logged in equals true, let is admin equals false. Let can access admin panel equals is logged in and is admin. Console log can access admin panel, output, false. Unary operators operate on a single operand, plus increment. Increases the value of a numeric variable by 1 count plus plus, postfix. Increments after the value is used. Plus count prefix, increments before the value is used. Decrement decreases the value of a numeric variable by 1. Count postfix. Count prefix, plus unary plus, converts its operand to a number if possible. Console log plus 10, output, 10 number. Unary minus converts its operand to a number and negates it. Console log minus 5, output, minus 5. Example, let counter equals 0, counter plus plus. Counter is now 1. Console log counter, output, 1. Let x equals 5, let y equals x plus plus. Y gets 5, then x becomes 6. Console log x x y y, output, x 6 y 5. Let a equals 5. Let b equals plus plus a becomes 6, then b gets 6. Console log a b b, output a 6 b 6. Ternary conditional operator. A concise way to write a simple if-else statement. Syntax, condition, value if true, value if false. Example, let is adult equals age equals 18. Yes, no, console log is adult, output. Yes, if age is 20 from previous example. Operator precedence and associativity. Just like in mathematics, remember PEMDAS, BODMAS? Operators in JavaScript have a specific order of precedence, determining which operations are performed first. Precedence, multiplication and division have higher precedence than addition and subtraction. Let result equals 10 plus 5, 2. Multiplication, 5, 2 equals 10 happens first. Console log result, output, 20, 10 plus 10. You can use parentheses to explicitly control the order of operations, just like in math. Let result with parentheses, 10 plus 5, 2. Addition 10 plus 5 equals 15 happens first. Console log result with parentheses, output, 30, 15, 2. Associativity. When operators have the same precedence, e.g., plus, and associativity determines whether they are evaluated from left to right or right to left. Most operators like arithmetic, logical, comparison are left to right associative. Let calc equals 10, 5 plus 2, 10, 5 plus 2, 5 plus 2, 7. Console log calc, output, 7. Practical application, calculating a bill. Let's put some of these concepts into practice. Imagine you're writing a small program to calculate a total bill at a restaurant. Variables for items and prices. Const appetizer price equals 12.50. Using const, as these prices are fixed for now. Const main course price equals 25.00. Const drink price equals 4.00. Let number of appetizers equals 2. Using let as quantities can chain. Let number of main courses equals 1. Let number of drinks equals 3. Calculate subtotal using arithmetic operators. Let subtotal equals appetizer price number of appetizers plus main course price number of main courses plus drink price number of drinks. Console log subtotal, subtotal output, subtotal 61.00. Add tax e.g. 8%. Const tax rate equals 0.08. 8% as a decimal, const because tax rate is fixed. Let tax amount equals subtotal tax rate. Console log tax amount, output, tax amount. 4.88. Calculate total bill before tip. Let total before tip equals subtotal plus tax amount. Console log total before tip, output, total before tip. 65.88. Decide on tip based on total. Let tip percentage. Using a comparison operator and ternary operator for a simple decision. Tip percentage equals total before tip 50, 0.20, 0.15, 20% tip if bill 50, else 15%. Let tip amount equals total before tip percentage. Console log tip amount, output. Tip amount 13.176 if tip is 20%. Calculate final bill. Let final bill equals total before tip plus tip amount. Console log, final bill, output, final bill, 79.056. Round to 2 decimal places for currency, common practical step. We'll learn more about functions later, but this demonstrates a practical use. Final bill equals parse float, final bill to fixed 2. Console log, final bill rounded, final bill, output, final bill rounded, 79.06. This small example uses const for fixed values, appetizer price, tax rate. Let for values that change, number of appetizers, subtotal, final bill, arithmetic operators, asterisk, plus, and a comparison with the ternary operator. Common pitfalls and troubleshooting. V's . This is the most common and often subtle mistake for beginners. Always default to strict equality to avoid unexpected type coercion. Use only when you explicitly need type coercion, and even then, often explicit conversion is clearer. Misunderstanding NaN. Be aware that NaN is not a number, but is itself a number type. And NaN NaN is false. Use isNaN. To reliably check for NaN variable scope, we briefly mentioned var behavior. Where a variable is declared impacts where it can be accessed. Forgetting this can lead to reference errors. We'll cover this in depth in Chapter 5. Typographical errors. A simple typo in a variable name, e.g., user enemy instead of username, will result in an uncaught reference error in your browser console, telling you the variable is not defined. Pay close attention to spelling. Summary. You've just built the vocabulary of JavaScript. You now know how to store data using let and const. Identify different data types like strings, numbers, and booleans. Perform operations using arithmetic, assignment, comparison, and logical operators. Understand type coercion and why strict comparison is preferred. Control operator evaluation order using parentheses. These are the fundamental building blocks upon which all more complex programs are constructed. In the next chapter, we'll learn how to make our programs smart by allowing them to make decisions and repeat actions, using conditional statements and loops. Further reading, MDN Web Docs, Variables. MDN Web Docs, Data Structures, Data Types. MDN Web Docs, Expressions and Operators. Chapter 3, Directing the Flow, Conditionals and Loops. In the previous chapter, we learned how to store data using variables and how to manipulate that data using various operators. This knowledge allows us to perform calculations and keep track of information. But what if we want our programs to be more intelligent? What if we want them to make decisions, to choose different paths based on certain conditions, or to perform the same task multiple times without repeating code? This is where control flow statements come into play. They dictate the order in which individual statements or instructions are executed. The two primary categories we'll explore in this chapter are conditionals, for making decisions, and loops, for repeating actions. Think of yourself playing a board game. Conditionals are like the if cards. If you land on this space, then draw a card, else move 2 spaces. Loops are like rolling the dice and moving your piece. You repeat the action of moving your piece, square by square, until you've moved the number of spaces indicated by the dice roll. Let's dive into making our programs smarter. Conditional statements. Making decisions. Conditional statements allow your program to execute different blocks of code based on whether a specified condition is true or false. 1. The if, and else statements. This is the most common way to make decisions in JavaScript. If executes a block of code if the condition specified is true. Else if, used after an if or another else if to check an additional condition if the preceding one was false. Else, executes a block of code if none of the preceding if or else if conditions were true. Syntax, if condition 1. Code to execute if condition 1 is true. Else if condition 2. Code to execute if condition 1 is false and condition 2 is true. Else, code to execute if condition 1 is false and condition 2 is false. Example, checking a user's age for access. Let user age equals 17, if user age equals 18. Console log, you are old enough to enter. Else, console log, sorry, you must be 18 or older to enter. Output, sorry, you must be 18 or older to enter. Let's change the age. user age equals 25, if user age equals 18. Console log, welcome, you are old enough to enter. Else, console log, sorry, you must be 18 or older to enter. Output, welcome, you are old enough to enter. Example, multiple conditions with else if. Let score equals 85, let grade. If score equals 90, grade equals A, else if score equals 80, will only be checked if score 90. Grade equals B, else if score equals 70, will only be checked if score 80. Grade equals C, else if score equals 60, will only be checked if score 70. Grade equals else will be executed if score 60. Grade equals F. Console log, your score is score, which is a grade. Output, your score is 85, which is a grade B. Important note on conditions. The condition inside the parentheses of an if statement must evaluate to a Boolean true or false value. If you provide a non-Boolean value, JavaScript will implicitly convert it into a Boolean according to its truthy and falsy rules discussed in Chapter 2. Example of truthy/falsy. Let username equals. An empty string is falsy. If username evaluates to false because it's an empty string. Console log, hello plus username, else. Console log, please enter your name. Output, please enter your name. Username equals Sarah. A non-empty string is truthy. If username, console log, hello plus username. Output, hello Sarah. 2. The switch statement. The switch statement is an alternative to a long else if chain when you are checking a single variable against multiple specific, discrete values. Syntax, switch expression. Case value 1. Code to execute if expression equals value 1. Break important, exits the switch block. Case value 2. Code to execute if expression equals value 2. Break, default, code to execute if no case matches. Optional, no break needed if it's the last statement. Example, determining the day of the week. Let day of week equals 3. 1 for Monday, 2 for Tuesday, etc. Let day name, switch day of week. Case 1, day name Monday, break case 2. Day name Tuesday, break case 3. Day name Wednesday, break. Case 4, day name Thursday, break. Case 5, day name Friday, break. Case 6, day name Saturday, break. Case 7, day name Sunday, break. Default, day name equals invalid day. Console log, today is day name. Output, today is Wednesday. Important, the break keyword in switch. Without a break statement at the end of each case block, the execution will fall through to the next case block, regardless of whether its value matches. This is rarely desired behavior and is a common source of bugs. The break tells JavaScript to exit the switch statement immediately. When to use if-else versus switch, if-else. Best for checking conditions based on ranges, e.g., score equals 90, complex logical expressions, e.g., age 18 and has license, or when your conditions don't relate to a single variable. Switch. Best when you have a single expression and want to execute code based on its exact value, e.g., specific numbers, strings, or enum-like values. Often more readable than a long if-else-if chain for such scenarios. 3. The ternary operator, conditional operator. The ternary operator provides a shorthand for a simple if-else statement, often used for assigning a value based on a condition. It's especially useful when you need to return one of two values. Syntax, condition, expression if true, expression if false. Example, assigning a status message. Let is raining equals true. Let weather message equals is raining. Don't forget your umbrella. Enjoy the sunny weather. Console log, weather message. Output, don't forget your umbrella. Is raining equals false. Weather message equals is raining. Don't forget your umbrella. Enjoy the sunny weather. Console log, weather message. Output, enjoy the sunny weather. While concise, avoid nesting ternary operators too deeply as it can quickly become unreadable. Logical operators and revisited. In Chapter 2, we introduced and, or, and, not. These are incredibly powerful when combined with conditional statements to create complex decision-making logic. And, both conditions must be true. Let age equals 22, let has ticket equals true. If age equals 18 and has ticket. Console log, welcome to the concert, else. Console log, you cannot enter. Output, welcome to the concert. OR, at least one condition must be true. Let is VIP equals false. Let knows password equals true. If is VIP knows password. Console log, access granted to the secret room. Else. Console log, access denied. Output, access granted to the secret room. Not, inverts a Boolean value. Let is authenticated equals false. If is authenticated are equivalent to. If is authenticated equals false. Console log, please log in to continue. Output, please log in to continue. Loop statements, repeating actions. Loops allow you to execute a block of code repeatedly until a certain condition is met. This is fundamental for tasks like processing lists of data, simulating events, or performing calculations that require iteration. 1. The for loop. The for loop is one of the most common loops and is typically used when you know exactly how many times you want the loop to run, or when you need to iterate a specific number of times based on a counter. Syntax for initialization, condition, increment, decrement. Code to execute repeatedly. Initialization, executed once at the beginning of the loop. Often used to declare and initialize a counter variable, e.g., let I equals 0. Condition, evaluated before each iteration. If true, the loop continues. If false, the loop terminates. Increment, decrement, executed after each iteration. Used to update the counter variable, e.g., I++, I plus equals 2. Example, counting from 1 to 5. For let I equals 1, I lesser equal 5, I++. Console log count, I. Output, count 1, count 2, count 3, count 4, count 5. Example, iterating backwards. For let I equals 10, I equals 0, I equals 2. Console log countdown, I. Outputs countdown, 10, countdown, 8, countdown, 6, countdown, 4, countdown, 2, countdown, 0, 2. The while loop. The while loop executes a block of code as long as a specified condition remains true. It's often used when you don't know in advance how many times the loop will run, and the repetition depends on a dynamic condition. Syntax, while condition. Code to execute repeatedly. Make sure to include some way to change the condition, so the loop eventually terminates, or you'll have an infinite loop. Example, simulating rolling a dice until a specific number is rolled. Let dice roll equals 0, let attempts equals 0, while dice roll equals 6. Dice roll equals math floor math random, 6 plus 1. Generates a random number from 1 to 6. Attempts plus plus, console log attempts, rolled a dice roll. Console log, it took attempts to roll a 6. Output might look like attempt 1, rolled a 3. Attempt 2, rolled a 1. Attempt 3, rolled a 6. It took 3 attempts to roll a 6. Warning, infinite loops. If the condition in a while loop never becomes false, the loop will run forever, freezing your program and potentially your browser tab or computer. Always ensure there's a mechanism within your while loop to eventually make the condition false. 3. The do-while loop. The do-while loop is similar to the while loop, but with one crucial difference. It guarantees that the code block within the loop will execute at least once, even if the condition is initially false. The condition is checked after the first execution of the block. Syntax, do. Code to execute at least once, and then repeatedly as long as the condition is true. While condition, example, ensuring user input. Let password, do. Password equals prompt, please enter a password, at least 6 characters. While password equals null, password length 6. Use a secure password in real apps. Console log, password set successfully. In this example, the prompt will always show at least once, and continue to show until the password is not null, meaning the user didn't click cancel, and its length is 6 or more. Loop control statements, break and continue. Inside any loop, you can use special keywords to modify its flow. Break immediately terminates the current loop or switch statement. Execution continues with the statement immediately following the loop. Example, finding the first prime number in a range. For let I equals 10, I lesser equal 20, I plus plus. Let is prime equals true. For let j equals 2, j plus plus. If I% equals 0, is prime equals false. Break, exit the inner loop if a divisor is found. If is prime, console log, the first prime number found is I, break, exit the outer loop once the first prime is found. Output, the first prime number found is 11. Continue, skips the rest of the current loop iteration and moves to the next iteration. Example, printing odd numbers. For let I equals 1, I lesser equal 10, I plus plus. If I% 2 equals 0. If I is an even number. Continue, skip the rest of this iteration and go to the next I. Console log odd number, I. Output odd number, 1. Odd number, 3. Odd number, 5. Odd number, 7. Odd number, 9. Iterating over collections with for, of, and for ... in. Besides the traditional for loop, JavaScript provides specialized loops for iterating over collections of data. 1. The for of loop E6 feature. The for of loop is used to iterate over iterable objects, such as arrays, strings, maps, sets, and more. It directly gives you the value of each element in the collection. Syntax. For variable of iterable. Code to execute for each element. Example, iterating over an array of fruits. Const fruits equals apple, banana, cherry, for const fruit of fruits. Console log I love fruit. Output I love apple, I love banana, I love cherry. Example, iterating over a string characters. Const my name JavaScript, for const char of my name. Console log char. Output JavaScript each on a new line. The for of loop is generally the preferred way to iterate over the elements of an array when you don't need the index. 2. The for ... in loop. The for ... in loop is used to iterate over the enumerable properties, keys, of an object. It is generally not recommended for iterating over arrays, as it can return unexpected properties and does not guarantee the order of elements. Syntax for variable in object. Code to execute for each property key. Example, iterating over object properties. Const car equals make Toyota, model Camry, year 2020. For const key in car, console log $key, car key, use bracket notation to access value with key. Outputs make Toyota, model Camry, year 2020. Common pitfall with for ... in and objects. The for ... in loop not only iterates over an object's own properties, but also inherited properties from its prototype chain. To ensure you only access the object's own properties, you should use the hasOwnProperty method. For const key in car, if car has own property key, console log $key, car key. We'll delve deeper into objects and their properties in Chapter 8. Practical application, a simple quiz game. Let's combine conditionals and loops to create a very basic text-based quiz game. Const questions equals. Question, what is 2 plus 2? Answer, 4. Question, what is the capital of France? Answer, Paris. Question, which planet is known as the red planet? Answer, Mars. Let score equals 0. Console log, welcome to the JavaScript quiz. Loop through each question. For let I equals 0, I questions length, I plus plus. Const current question equals questions I. Let user answer equals prompt, current question question. Prompt is a browser-only function. Convert user answer to lowercase for case-insensitive comparison. If user answer equals null, check if user didn't click cancel. User answer equals user answer to lowercase. Check if the answer is correct using a conditional. If user answer equals current question answer to lowercase. Console log correct, score plus plus, increment score. Else, console log wrong. The correct answer was current question answer. Console log, separator for readability. Display final score using conditional feedback. Console log quiz finished. Your final score is score out of questions length. If score equals questions length, console log, excellent, you got all questions correct. Else if score equals questions length /2. Console log, good job, you passed the quiz. Else, console log, keep practicing, you can do better. This example uses an array, which we'll cover properly in Chapter 8, to store questions. A for loop to iterate through them, if-else statements to check answers, and further if-else to give feedback based on the final score. Common pitfalls and troubleshooting. Infinite loops, the most dangerous loop error. Always double-check your while and do-while conditions to ensure they will eventually become false. For loops, ensure your increment-decrement step moves towards satisfying the condition. Off by one errors. In for loops, precisely handling the condition, v's less or equal, is crucial. For arrays, which are zero-indexed, iterating from 0 to array length 1, i.e., I array length is the correct pattern. Forgetting break and switch leads to unexpected fall-through behavior where multiple cases execute. Misunderstanding for ... and v's for of. Remember to use for iterating over array values, and for ... in for object keys, and be cautious with has own property. For loops, let I equal 0, I array length, I++ is perfectly valid and gives you access to the index. Summary. You've just gained the power to make your programs dynamic and adaptive. You can now use if, and else to control program flow based on conditions. The switch statement offers a clean alternative for multiple specific choices. The ternary operator provides concise conditional assignments. For while and do while loops enable you to repeat tasks efficiently. Break and continue give you fine-grained control over loop execution. For, of, and for ... in simplify iteration over collections. With variables, data types, operators, conditionals, and loops, you now have the fundamental tools to write almost any basic program. In the next chapter, we'll introduce functions, a crucial concept for organizing and reusing your code, making your programs even more efficient and manageable. Further reading, MDN Web Docs, Control Flow and Error Handling. MDN Web Docs, Loops and Iteration. Chapter 4, Function First, Crafting Reusable Code. So far, we've learned how to store and manipulate data, and how to control the flow of our programs with conditionals and loops. These are powerful tools, but as your programs grow, you'll find yourself writing the same or very similar blocks of code multiple times. This leads to repetition, makes your code harder to read, and creates a nightmare every time you need to fix a bug or add a new feature, because you have to update it in every place it appears. This is where functions come to the rescue. A function is a block of organized, reusable code that performs a specific task. Think of functions as mini programs within your main program. Instead of writing the complete set of instructions every time, you can define a function once and then call or invoke it whenever and wherever you need that task performed. Why use functions? The concept of functions is central to almost every programming language. They offer several key advantages: reusability, dry, don't repeat yourself. This is the primary benefit. Write a piece of code once, define it as a function, and then use it many times. Modularity. Functions break down a large program into smaller, manageable, and self-contained units. This makes your code easier to write, debug, and understand. Each function can focus on a single responsibility. Readability. Giving a function a meaningful name, calculate total, send email, validate input, makes your code much easier to understand at a glance. Maintainability. If a piece of logic needs to be changed or a bug needs to be fixed, you only have to do it in one place, the function definition, instead of searching for and modifying every instance of that code throughout your program. Abstraction. Functions allow you to hide complex implementation details. You just need to know what the function does, not necessarily how it does it. Defining functions. The traditional ways. There are several ways to define functions in JavaScript. We'll start with the two traditional declarations, function declarations and function expressions. 1. Function declaration. This is often the most straightforward way to define a function. It uses the function keyword, followed by the function name, a list of parameters in parentheses, and finally the function body enclosed in curly braces. Syntax, function name, parameter 1, parameter 2. Code to be executed when the function is called. The function body. Example, a simple function that greets a user. Function greet, console log, hello, welcome to our app. Calling or invoking the function, greet, output hello, welcome to our app, greet, output hello, welcome to our app. Can call multiple times. Parameters and arguments. Most functions need some input to perform their task. These inputs are called parameters. When you call the function, the actual values you pass into it are called arguments. Example, greeting a specific user. Function greet user name. A name is a parameter. Console log hello, name, welcome to our app. Calling the function with arguments, greet user, Alice. Alice is an argument. Output hello Alice, welcome to our app. Greet user, Bob. Bob is an argument. Output hello Bob, welcome to our app. You can define multiple parameters, separated by commas. The order of arguments when calling a function must match the order of parameters in the function definition. Function add, num1, num2. Num1 and num2 are parameters. Console log, num1 plus num2. Add 5, 3, 5 and 3 are arguments. Output, 8. Add 10, 20, output, 30. Return values. So far, our functions have only displayed output in the console. Often, you want a function to compute a value and give it back to the part of the code that called it. This is done using the return keyword. When return is encountered, the function immediately stops executing, and the value specified after return is sent back as the function's result. Example: a function that calculates something and returns the result. Function calculates sum, a, b. Let sum equals a plus b, return sum. The function gives back the value of sum. Let result 1 calculate sum, 10, 5. The result of calculate sum 10, 5, which is 15, is stored in result 1. Console log result 1, output, 15. Let result 2 equals calculate sum, 7, 3. Console log result 2, 2. Output, 20, because 10, 2. If a function does not explicitly return a value, it implicitly returns undefined. Function do nothing. This function does not have a return statement. Let value equals do nothing. Console log value, output, undefined. 2. Function expression. A function expression is when you define a function as part of an expression, usually by assigning it to a variable. The function itself can be named or anonymous, without a name. Anonymous function expressions are very common. Syntax: const function name equals function, parameter 1, parameter 2. Code to be executed. Don't forget the semicolon. Example: anonymous function expression. Const say goodbye equals function. The function has no name here, but it's assigned to say goodbye. Console log goodbye, say goodbye. Call it like a regular function. Output: goodbye. Example: named function expression, less common but possible. The name myfuncexp is only useful for recursion or debugging within the function itself, not for calling it externally. Const another greeting equals function myfuncexp name. Console log greetings name, another greeting, Charlie. Output: greetings Charlie, myfuncexp David. This would cause an error. Myfuncexp is not defined. Key difference: hoisting. This is an important distinction between function declarations and function expressions. Hoisting. Function declarations are hoisted. This means you can call a function declaration before it's defined in your code. JavaScript moves function declarations to the top of their containing scope during compilation. Say hello, this works. Output: hello there. Function say hello. Console log hello there. Function expressions are not hoisted in the same way. You cannot call a function expression before it's assigned to its variable. The variable declaration is hoisted, but its assignment, the function definition, is not. Since const and let variables are in a temporal dead zone until their declaration line is executed, trying to call the function before that will result in an error. Greet guest: this would cause a reference error. Cannot access greet guest before initialization. Const greet guest equals function. Console log welcome guest, greet guest. This works. This behavior of function expressions is often considered safer, as it forces you to define functions before you use them, making the code's flow more explicit. Arrow functions E6+. Introduced in ECMAScript 6, E6, arrow functions provide a more concise syntax for writing function expressions. They are particularly favored for short, single expression functions. Syntax: const function name equals parameter 1, parameter 2 equals function body. Example: simple arrow function. Const say hello arrow equals console log hello from an arrow function, say hello arrow. Output: hello from an arrow function. Concise body, implicit return. If the function body consists of a single expression, you can omit the curly braces and the return keyword. The result of that expression will be implicitly returned. Const multiply equals a b equals a b, implicit return. Console log multiply 4 5, output 20. If your arrow function has only one parameter, you can also omit the parentheses around the parameter list. Const double equals num2, single parameter, no parentheses. Console log double 7, output 14. If an arrow function returns an object literal implicitly, you need to wrap the object literal in parentheses to avoid ambiguity with the function body block. Const create user equals name age equals name age, return an object. Console log create user, Emily 28, output, name, Emily age 28. Key differences of arrow functions, conciseness, shorter syntax. This binding, arrow functions handle the this keyword differently than traditional functions. This is a more advanced topic we'll cover in Chapter 9, but for now, know they don't have their own this context. No arguments object. Arrow functions do not have their own arguments object. Not hoisted. Like function expressions, arrow functions are not hoisted. For general-purpose functions, either function declarations or modern function expressions with const and arrow functions are common. Arrow functions are especially popular for callbacks and short, functional operations. Immediately invoked function expressions, IIFEs. An IIFE, pronounced IFE, is a function expression that is executed immediately after it is defined. They are often used to create a private scope for variables, preventing them from polluting the global scope. Syntax, function. Code inside this function runs immediately. Variables declared here are private to this function. The final parentheses immediately invoke the function. Example, function. Let message equals, this message is private within the IIFE. Console log message, output, this message is private within the IIFE. Console log message, this would cause a reference error, message is not defined. IIFEs are less common with the advent of EASE 6 modules, Chapter 15, which provide a built-in module system for creating private scopes. However, you might still encounter them in older code bases or specific scenarios. Practical application, refactoring with functions. Let's revisit our quiz game from Chapter 3 and refactor it using functions to make it cleaner and more modular. Function to display a question and get user's answer. It encapsulates the logic for asking and formatting the answer. Function ask question, question text. Let user answer equals prompt, question text. If user answer equals null, return user answer to lowercase, return lowercase answer or null. Return null if user cancels. Function to check an answer and update score. It takes current and correct answer, and current score returns updated score. Function check answer, user answer, correct answer, current score. If user answer equals correct answer to lowercase. Console log correct, return current score +1. Return incremented score. Else, console log wrong. The correct answer was correct answer. Return current score, return score unchanged. Function to give final feedback based on score. Function give quiz feedback, final score total questions. Console log quiz finished. Your final score is final score out of total questions. If final score equals total questions, console log excellent, you got all questions correct. Else if final score equals total questions /2. Console log good job, you passed the quiz. Else console log keep practicing, you can do better. Main quiz logic. Const questions equals. Question, what is 2 + 2? Answer, 4. Question, what is the capital of France? Answer, Paris. Question, which planet is known as the red planet? Answer, Mars. Let score equals 0. Console log, welcome to the JavaScript quiz. For let I equals 0, I questions length, I++. Const current question equals questions I. Use our new ask question function. Const user answer equals ask question, current question question. Only check answer if user provided 1, didn't click cancel. If user answer equals null, use our new check answer function. Score equals check answer user answer, current question answer, score. Else, console log, question skipped. Console log, use our new give quiz feedback function. Give quiz feedback, score, questions length. Notice how much cleaner and more readable the main quiz logic becomes now that we've abstracted away the details into named functions. Each function has a single responsibility, making it easier to understand, test, and potentially reuse in other parts of a larger application. Common pitfalls and troubleshooting. Forgetting to call the function. Defining a function doesn't execute its code. You must explicitly call it using its name followed by parentheses, function name. Incorrect number order of arguments. If a function expects 2 parameters, but you pass only 1 argument, the missing parameter will be undefined. If you pass too many, the extra ones will be ignored, unless the function is designed to handle them. Return v's. Console log. Remember, console log is for displaying output in the console for debugging or user information. Return is for sending a value back to the part of the code that called the function so it can be used further. A function that console log s a result doesn't return anything usable by other parts of the code. It implicitly returns undefined. Hoisting issues. Trying to call a function expression or arrow function before its definition will lead to reference errors. Summary. Functions are the workhorses of JavaScript. By now, you should understand what functions are and why they are essential for writing modular, reusable, and readable code. The difference between function declarations, which are hoisted, and function expressions, which are not. How to use parameters to pass data into functions and return values to get results back. The concise syntax and specific characteristics of arrow functions. The concept of IIFEs for creating private scope. You've learned how to break down complex tasks into smaller, manageable pieces, a crucial skill for any developer. In the next chapter, we'll delve into the concept of scope, which determines where your variables and functions live and can be accessed within your program. Further reading, MDN Web Docs, Functions, MDN Web Docs, Arrow Function Expressions. Chapter 5, Scope, where your variables live. In the previous chapters, we've learned how to declare variables and write functions. You've seen that variables hold values and functions encapsulate blocks of code. But where exactly do these variables and functions live within your program? And more importantly, from where in your code can you access them? This concept is called scope. Understanding scope is crucial for writing correct, bug-free, and maintainable JavaScript. It determines the accessibility, visibility of variables, functions, and objects in different parts of your code. If you try to access a variable outside its defined scope, you'll encounter a reference error. Think of scope as different rooms in a house. Each room, scope, has its own belongings, variables, and functions. Some belongings might be visible and accessible from anywhere in the house, global scope, while others are only visible and accessible from within a specific room, local scope. You can't just walk into any room and expect to find everything. You need permission or presence within that specific room. In JavaScript, there are several kinds of scope, primarily global scope, function scope, or local scope. Block scope, introduced with let and const. Let's explore each one. 1. Global scope. A variable or function declared in the global scope is accessible from anywhere in your JavaScript code, including within functions and other blocks. There is only one global scope in a program. How to declare in global scope. Declare a variable outside of any function or block using let, const, or var. In a browser environment, variables declared with var or traditional function declarations outside of any specific context become properties of the global window object. Let and const variables declared globally are also global, but they don't attach to the window object directly. Example. Variable declared in the global scope. Const app name, my awesome app. Let user count equals 0, function welcome user. These global variables are accessible here. Console log welcome to app name, console log current user count, welcome user output. Welcome to my awesome app, current user count, 0. User count equals 1. Global variable can be modified. Console log user count updated. User count, output, user count updated. 1. Pitfalls of global variables. While convenient, relying heavily on global variables is generally considered a bad practice because name conflicts. In larger applications, multiple parts of the code, or third-party libraries, might define variables with the same name, leading to accidental overwriting and difficult-to-debug issues. Harder to debug. Any part of your code can modify a global variable, making it hard to trace where a variable's value changed unexpectedly. Reduced modularity. Functions become less self-contained if they rely on global variables instead of receiving data as parameters. Two-function scope or local scope. Every time you define a function, you create a new function scope. Variables and functions declared inside a function are local to that function and cannot be accessed from outside it. How to declare in function scope. Declare a variable using let, const, or var inside a function. Define a function inside another function. Example, function calculate score. Let score equals 100. Score is local to calculate score. Const bonus equals 20. Bonus is local to calculate score. Console log inside function. Score is score, bonus is bonus. Output. Inside function. Score is 100, bonus is 20. Calculate score. Console log score. This would cause a reference error. Score is not defined. Console log bonus. This would cause a reference error. Bonus is not defined. Nested functions and scope chain. Functions can be nested inside other functions. When this happens, a hierarchy of scopes is created, forming a scope chain. When JavaScript looks for a variable, it first checks the current innermost scope. If it doesn't find the variable there, it moves up to the parent scope, then to its parent, and so on until it reaches the global scope. If the variable isn't found anywhere along this chain, a reference error is thrown. Example. Scope chain. Const global var I am global, global scope. Function outer function. Const outer var I am from outer function scope. Function inner function. Const inner var I am from inner function scope. Console log inner var, accessible, yes, current scope. Console log outer var, accessible, yes, parent scope. Console log global var, accessible, yes, grandparent global scope. Inner function, call inner function from outer function. Console log inner var would cause reference error. Inner var is not defined. Outer function, call outer function from global scope. Console log outer var would cause reference error. Outer var is not defined. Console log inner var would cause reference error. Inner var is not defined. This hierarchical access is fundamental to how JavaScript manages variables and enables powerful patterns like closures, which we'll discuss in a later chapter. 3. Block scope. Block scope was introduced with ease 6, let and const. A block is typically a set of statements enclosed in curly braces. This includes if statements, for loops, while loops and simple code blocks. Variables declared with let and const inside a block are only accessible within that block and its nested blocks. Example, block scope with let and const. If true, let block let, I am block scoped with let. Const block const, I am block scoped with const. Var function var, I am function scoped despite the block. Don't use var in blocks this way. Console log block let, output. I am block scoped with let. Console log block const, output. I am block scoped with const. Console log function var, output. I am function scoped despite the block. Console log block let, reference error. Block let is not defined. Console log block const, reference error, block const is not defined. Console log function var, output. I am function scoped despite the block if not inside another function. If this block were inside a function, function var would be function scoped. But if it's in the global scope, it becomes global. This is var's confusing behavior. The example above highlights a key difference between var and let const. Var is function scoped. If var is declared inside a function, it's local to that function. If declared outside any function, even inside a block, it's global. Let and const are block scoped. They are confined to the nearest enclosing curly braces. This makes let and const much more predictable and safer to use, as variables don't leak out of the blocks where they are intended to be used. This is a major reason why let and const are preferred over var. Lexical scoping. JavaScript uses lexical scoping, also known as static scoping. This means that the scope of a variable is determined by its position in the source code at the time of writing lexical analysis, not at the time of execution. This is why inner function in our scope chain example can access outer var and global var, because it is defined inside outer function and they are all nested within the global scope. Lexical scoping determines this relationship from the structure of the code, not from where functions are called. Hoisting revisited. You briefly encountered hoisting in Chapter 4 when discussing function declarations versus expressions. Let's look at it more formally in the context of scope. Hoisting is JavaScript's mechanism where variable and function declarations are moved to the top of their containing scope during the compilation phase, before the code actually executes. Var declarations are hoisted. The declaration var favorite color is hoisted to the top of its function or global scope. The initialization equals blue remains exactly where you put it. Example, console log favorite color. Output undefined declaration is hoisted, but not value. Var favorite color equals blue, console log favorite color, output, blue. During compilation, the JavaScript engine might conceptually interpret the above code as var favorite color, declaration is hoisted, console log favorite color exists but its value is undefined. Favorite color blue. Assignment happens here. Console log favorite color. This behavior of var can be confusing and lead to bugs, especially when variables are used before they are assigned. Let and const declarations are also hoisted, but with a temporal dead zone, TDZ. Let and const variables are also hoisted to the top of their block scope. However, unlike var, they are not initialized with undefined. They enter a temporal dead zone, TDZ, from the start of their block until their declaration line is executed. Any attempt to access them within the TDZ will result in a reference error. Example, console log user age, reference error, cannot access user age before initialization. Let user age equals 30, console log user age, output, 30. The TDZ makes let and const safer because it forces you to declare and, for const, initialize variables before you use them, making the code's dependencies explicit. Function declarations are hoisted. The entire function declaration is hoisted, meaning you can call a function declared this way before its definition in the code. Example, say hi, output, hi there, function say hi. Console log, hi there. Function expressions and arrow functions are not fully hoisted. Only the variable const greeting func is hoisted like any other let or const. The function assignment itself is not. Since const and let are subject to the TDZ, you cannot call these functions before their definition. Example, greeting func, reference error. Cannot access greeting func before initialization. Const greeting func equals console log greetings from arrow function. Greeting func, output, greetings from arrow function. Understanding hoisting helps explain why certain reference errors occur, particularly when switching from var to let const. It reinforces why let and const are preferred for their more predictable block-scoped behavior and elimination of var's confusing undefined hoisting. Practical application. Managing user state in a web app. Let's imagine a simple user profile page. We want to display user information, but some data might only be visible to logged-in users who are also administrators. Scope helps us manage what data is accessible where. Global scope. These variables might be set when the application starts or from backend data. Const appname user dashboard. Accessible everywhere. Let current user equals null. Will store logged-in user data, null initially. Function initialize app. Console log welcome to the appname. Display login prompt. Function display login prompt. This function is purely for demonstration. Real login would be more complex. Console log, please log in to view your profile. Simulate a successful login after some time, not real JS async, just concept. Set timeout equals. Setting current user in global scope. Current user equals id 101. Name, Alice Wonderland. Email, alice@example.com. Is admin, true. Settings, theme, dark notifications, true. Console log, user logged in, render user profile, 1000. Wait 1 second to simulate login time. Function render user profile. Accessing global scope. If current user, check if a user is logged in. Console log \n, current user .names profile. Console log email, current user email, block scope within an if statement. If current user is admin, let admin message equals you have administrator privileges. Console log admin message. accessible only within this if block. Display admin controls, current user settings. Console log admin message. Reference error. Admin message is not defined outside its block scope. Simulate fetching additional user data, which is only local to this function. Function scope. Let fetch data equals additional private data, e.g., last login time. Console log internal data, fetch data, else. Console log \n no user logged into display profile. Function display admin controls, user settings. User settings is a parameter local to this function. Function scope. Const control panel name, admin control panel, local to display admin controls. Console log \n control panel name, console log current theme, $user settings theme. Block scope within a for loop. For let I equals 0, I3. I++. Let feature equals feature I+1. Console log admin feature available. Console log feature. Reference error, feature is not defined outside its block scope. Initialize app. In this example, app name and current user are in the global scope. Admin message lives only within the if current user is admin block scope. Fetch data lives only within the render user profile function scope. Control panel name lives only within the display admin controls function scope. Feature lives only within the for loops block scope. This demonstrates how different levels of scope prevent variables from interfering with each other and help keep your code organized. Common pitfalls and troubleshooting. Reference error. This is the telltale sign that you're trying to access a variable outside its defined scope. Double-check where the variable was declared, let, const, or var, and where you are trying to use it. Accidental global variables. If you forget to use let, const, or var, or function, when declaring a variable inside a function in non-strict mode, JavaScript will automatically make it a global variable. This is bad practice and can lead to unexpected side effects. Always declare your variables. Function create name. Username equals Bob, no let, const, or var. Create name, console log username. Output Bob surprise, username is global. To prevent this, always write your JavaScript in strict mode by adding useStrict at the top of your script file or within a function. In strict mode, username equals Bob would throw a reference error. Confusing var's scope. Remember that var does not have block scope, which is why let and const are preferred specifically for their cleaner block scoping behavior. Summary. Understanding scope is a significant step towards becoming a proficient JavaScript developer. You now grasp the concept of scope as the accessibility of variables and functions, the distinction between global scope, function scope, and block scope. How let and const provide modern, predictable block-level scoping, unlike var's function-level or global scope. The scope chain, which dictates how JavaScript resolves variable lookups in nested scopes. Lexical scoping, meaning scope is determined by where code is written. Hoisting and the temporal dead zone, explaining variable availability and common errors. With a solid grasp of scope, you are well equipped to manage variables effectively and write more robust, maintainable JavaScript code. In the next chapter, we'll shift our focus from core language features to how JavaScript interacts with the web page itself. The Document Object Model DOM. Further reading, MDN Web Docs, Scope. MDN Web Docs. var. MDN Web Docs, let. MDN Web Docs, const. MDN Web Docs, hoisting. Chapter 6, the Document Object Model DOM, bringing pages to life. So far, we've focused on the core JavaScript language. Variables, data types, logic, functions, and scope. These are the fundamental rules and tools of the language itself. Now, it's time to connect JavaScript to its most common environment, the web browser, and specifically, the web page that the user sees. This connection happens through the Document Object Model DOM. Imagine an HTML web page as a house. The HTML tags, HTML, head, body, h1, p, iframe, are like the blueprint and structural components of the house. The DOM is like a fancy, interactive digital model of that house that JavaScript can directly manipulate. It's a programming interface for web documents. It represents the page so that programs can change the document structure, style, and content. The DOM represents the document as a tree of objects. Every element on a web page, from the HTML tag itself down to a single button or paragraph of text, becomes a node in this DOM tree. JavaScript can access and manipulate these nodes. Key idea: JavaScript doesn't directly interact with your HTML file. Instead, when the browser loads your HTML, it creates this tree-like representation, the DOM in memory. JavaScript then interacts with this in-memory DOM. Any changes you make with JavaScript are made to this DOM tree, and the browser then updates what you see on the screen to reflect those changes. Let's explore how to interact with this powerful model. 1. Selecting elements. Finding your way around the DOM tree. Before you can change an element, you need to find it. The DOM provides several methods to select specific elements or groups of elements from the document. A. Document get element by ID name. This is the fastest and simplest way to select a single element if it has a unique id attribute. It returns the element object, or null if no element with that ID is found. IDs should always be unique within a document. Example: PID equals introduction welcome to our site /p. Script: const intro paragraph equals document get element by ID introduction. Console log intro paragraph outputs the p element object. Script: b document get elements by class name. This method returns a live HTML collection, a special type of array-like object, of all elements that have the specified class name. If no elements are found, it returns an empty HTML collection. Example: div class equals product hard shirt /div. Div class equals product hard pants /div. Div class equals product hard sock /div. Script: const product hards equals document get elements by class name product hard. Console log product cards outputs an HTML collection of the 3 divs. You can loop through them. For let I equals 0, I product cards length. I++, console log product cards I text content, accessing the text content. Output shirt pants socks each on a new line. Script: remember that HTML collection is live, meaning if you add or remove elements with that class from the DOM, the collection automatically updates. See document query selector. This is a very powerful and commonly used method. It takes a CSS selector string as an argument and returns the first element in the document that matches that selector. If no element matches, it returns null. You can use any valid CSS selector string: ID, myid, class, myclass, tag name, pdiv, attribute name equals username, combinations, div.container p, input type equals text. Example: nav, a href equals class equals navlink active home /a. A href equals class equals navlink about a. Nav, img src equals image.jpg, alt equals description, date ID equals 123. Script: const active link equals document query selector, navlink active. Console log active link text content, output, home. Const first paragraph equals document query selector, p, if there were multiple paragraphs. Console log first paragraph returns the first p element. Const image element equals document query selector, im date ID equals 123, console log image element alt. Output, description. Script: document query selector all selector. Similar to query selector, but it returns a static node list of all elements that match the specified CSS selector. If no elements match, it returns an empty node list. Example: ul, li item 1 li item 2 li item 3 li, ul. Script: const list items equals document query selector all li, console log list items, outputs a node list of 3 li elements. You can loop through node list using for, of, or for each. For const item of list items, console log item text content, output item 1, item 2, item 3, each on a new line. List items for each item equals console log item text content. Another way to loop. Script: node list is static, meaning it won't update automatically if elements are added or removed from the DOM after it's created. This is a key difference from HTML collection. 2. Manipulating elements, changing content and attributes. Once you've selected an element, you can change its content, attributes, or even its style. A. Changing text content. text content, and inner HTML. Text content gets or sets the text content of the specified node and all its descendants. It's safer because it treats everything as raw text, preventing potential security vulnerabilities, like cross-site scripting or XSS, if you're inserting user-generated content. PID equals paragraph original text span with a span p. Script const para equals document get element by ID my paragraph, console log paratext content, output original text with a span, paratext content equals new text only, replaces all content, including tags, with plain text. Console log paratext content, output new text only. Script inner HTML gets or sets the HTML content, including tags, of the specified element. It's more powerful because it allows you to insert actual HTML structure, but use it with caution when dealing with untrusted input, as it can introduce security risks. Div ID equals container original content div. Script const container equals document get element by ID container, console log container dot inner HTML, output original content, container dot inner HTML new strongbold / strong content, inserts new HTML. The div now contains new strongbold / strong content, container dot inner HTML plus equals p appended paragraph p, appends more HTML. The div now contains new strongbold / strong content p appended paragraph p. Script b changing attributes get attribute, set attribute, remove attribute. HTML elements have attributes like src for images, href for links, class id. You can read and modify them. Element get attribute name, gets the value of an attribute. Element set attribute name, new value, sets or changes the value of an attribute. If the attribute doesn't exist, it's added. Element remove attribute name, removes an attribute. Example, imgid equals my image, src equals old.jpg, alt equals old image. RID equals my link, href equals old page HTML, target equals blank click here. Script const img equals document get element by ID, my image. Console log imget attribute src, output, old.jpg. Img set attribute, src new.jpg, change image source. Img set attribute alt, new image. Change alt text. Img set attribute width 200, add a new attribute. Const link equals document get element by ID my link. Link set attribute href, https example.com. Change link destination. Link remove attribute target, remove the target attribute. Script many common attributes, like id, class name, src, href value, can also be accessed directly as properties of the DOM element object. Img src equals another .jpg. Same as img set attribute src, another .jpg. Link href equals https mysite.com, 3 styling elements. Making things look good. You can change an element's appearance dynamically using JavaScript, either by directly manipulating its style properties or by adding removing CSS classes. A. Direct style manipulation, style. The style property of an element allows you to access and modify its inline CSS properties. Remember to use camel case for CSS properties that have hyphens, e.g., background color for background color. Example, button ID equals my button click me button. Script const button equals document get element by ID my button. Button style background color equals blue. Button dot style dot color equals white. Button style font family equals monospace. Button style padding equals 10px 20px. Button style border equals none. Script. While direct style manipulation works, it often leads to less maintainable code. For more complex styling changes, using CSS classes is generally preferred. B. Managing CSS classes, class list. The class list property provides a convenient way to add, remove, or toggle CSS classes on an element. This is the recommended approach for dynamic styling because it separates presentation, CSS, from behavior, JavaScript. Element class list add, class name, adds one or more classes. Element class list remove, class name, removes one or more classes. Element class list toggle, class name, adds the class if it's not present, removes it if it is. Element.classList.contains class name, checks if a class is present, returns true or false. Example. Style, highlight, border 2px solid orange, background color, yellow. Hidden, display, none. Style, PID equals status message. This is a regular message P. Button ID equals toggle highlight button. Button ID equals hide message, hide/show message button. Script, const status message equals document get element by ID status message. Const toggle highlight btn equals document get element by ID toggle highlight. Const hide message btn equals document get element by ID hide message. Toggle highlight btn add event listener click equals status message class list toggle highlight add remove highlight class. Hide message btn add event listener click equals status message class list toggle hidden add remove hidden class. Console log status message.classlist.contains highlight check if class exists. Script 4. Traversing the DOM. Navigating the tree. The DOM is a tree structure, so elements have relationships, parent, children, and siblings. You can navigate these relationships to find related elements. Element parent node returns the parent node of an element. Element children returns a live HTML collection of an element's child elements, excluding text nodes, comments, etc. Element first element child returns the first child element. Element last element child returns the last child element. Element next element sibling returns the next sibling element. Element previous element sibling returns the previous sibling element. Example. Div ID equals parent container. P first paragraph P. Span a span element span. P class equals last paragraph P. Div. Script. Const last paragraph equals document query selector. Last. Console log last paragraph parent node ID. Output. Parent container the div's id. Const parent equals document get element by ID parent container. Console log parent children length. Output. 3p span P. Console log parent first element child text content. Output. First paragraph. Console log parent last element child text content. Output. Last paragraph. Const span element equals document query selector span. Console log span element previous element sibling text content. Output. First paragraph. Console log span element next element sibling text content. Output last paragraph. Script. 5. Creating, appending, and removing elements. You're not limited to just modifying existing elements. You can also dynamically create new ones and add them to the page or remove existing ones. Creating new elements. Document create element tag name. This method creates a new HTML element node. The element is created in memory, but is not yet part of the actual web page. Example. Const new div equals document create element div. Creates a new div element. Const new heading equals document create element, h2. Creates a new h2 element. B. Appending elements, parent node append, child node, or parent node append child, child node. Once an element is created, you need to add it to the DOM tree to make it visible. These methods append the new element as the last child of a specified parent element. Append can append multiple nodes and strings. Append child can only append one node at a time. Example. Ul ID equals shopping list. Li milk li. Ul. Script. Const shopping list equals document get element by ID shopping list. Create a new list item. Const new item document create element, li. New item text content equals eggs, set its text content. Shopping list append child, new item, add it to the list. Create another item and add quickly. Const another item equals document create element, li. Another item text content equals bread. Shopping list append another item, coffee text node. Append multiple things. Script. After this script runs, the shopping list will contain li milk / lily eggs / lily bread / li coffee, text node. See removing elements, parent node remove child, child node, or child node remove. You can also remove elements from the DOM. Parent node remove child, child node requires knowing the parent of the element you want to remove. Child node remove. Modern, simpler. The element removes itself directly. Example. Div ID equals messages. PID equals first message. This message will be removed P. P keep this message P. Div script const messages div equals document get element by ID messages. Const first message equals document get element by ID first message. Using remove child requires parent. Messages div remove child first message. Using remove, simpler. First message remove removes the element directly. Script practical application, a dynamic task list to-do list. Let's combine what we've learned to create a simple interactive to-do list. DOCTYP HTML. HTML lang equals n. Head. Meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Initial scale equals 1.0. Title dynamic to-do list title. Style. Body font family. Sans serif max width 600px. Margin 20px auto, padding 20px, border 1px solid CCC, border radius 8px. H1 text align, center color 333. Task input width, calc 100% 70px. Padding 8px, margin right 10px, border 1px solid DDD, border radius 4px. Add task btn, padding 8px 15px. Background color, #007BFF, color, white border none border radius, 4px cursor pointer. Add task btn, hover, background color, 56b3. Task list style, none padding, 0 margin top, 20px. Task list background color, F9 F9 F9, border 1px solid E, padding, 10px, margin bottom, 5px display, flex, justify content, space between align items, center border radius 4px. Task list button, background color, DC 3545. Color, white border none padding, 5px 10px, border radius 3px, cursor, pointer, font size 0.8m. Task list button, hover background color, C82333. Style, head, body, H1 my to-do list H1. Div, input type equals text, ID equals task input, placeholder equals add a new task. Button ID equals add task btn add task button. Div, ul ID equals task list. Tasks will be added here by JavaScript. Ul, script, const task input equals document get element by ID, task input. Const add task btn equals document get element by ID add task btn. Const task list equals document get element by ID, task list. Function to add a new task item. Function add new task. Const task text equals task input value trim. Get input value and remove whitespace. If task text equals alert, please enter a task. Simple validation. Return, stop if input is empty. 1. Create new list item li and buts. Const list item equals document create element, li. Const remove btn equals document create element button. Remove btn text content equals remove. 2. Set text content of list item. List item text content equals task text. 3. Append the remove button to the list item. List item append, remove btn. Use append, as text will be set next to it. 4. Attach an event listener to the remove button. We'll cover event handling in detail in the next chapter. Remove btn add event listener click equals list item remove. Remove the parent li when button is clicked. 5. Append the new list item to the task list, the ul. Task list append child, list item. 6. Clear the input field for the next task. Task input value equals add task when button is clicked. Again, event handling details are in the next chapter. Add task btn add event listener, click, add new task. Add task when enter key is pressed in the input field. Task input add event listener key press, event equals. If event key equals, enter. Add new task. Script. Body. HTML. This example uses getElement by id to select elements. Create element to create new ones, text content to set their content, and append child append to add them to the DOM. It also introduces, briefly, as a teaser for the next chapter, add event listener to react to user interactions, common pitfalls and troubleshooting. Script placement. If your script tags are in the head without defer or async, and you try to select an element that hasn't been parsed yet, the selection method will likely return null. Always ensure the DOM is ready. Case sensitivity. HTML attributes and CSS properties often use hyphens, e.g., background color, but their JavaScript DOM counterparts typically use camel case, e.g., background color. Query selector versus query selector all. Remember, query selector returns only the first match or null, while query selector all returns a node list, even if it's empty or has only one item. If you expect multiple items, use query selector all and then loop through the returned node list. HTML collection versus node list. Be aware of whether a returned collection is live, HTML collection from getElementsByClassName, or static, node list from query selector all. For most purposes, converting to a true array, e.g., array dot from collection, before manipulating can prevent issues, especially when adding removing items while iterating. Security for inner HTML. Always avoid using inner HTML with untrusted user input, as it can be a major security vulnerability. Prefer text content when you just want to insert plain text. Summary: the DOM is the bridge between your JavaScript code and the visual web page. You now have the essential knowledge to understand the DOM as a tree-like representation of your HTML. Select elements efficiently using id, class, or powerful CSS selectors. Manipulate existing elements by changing their text content, inner HTML, and attributes. Control their appearance by modifying inline style properties or, preferably, by adding removing CSS class lists. Navigate the DOM tree using parent, child, and sibling properties. Dynamically create and manage elements by adding them to or removing them from the page. With these skills, you can bring your web pages to life, making them interactive and responsive to user input. In the very next chapter, we'll dive deeper into that last point: event handling, which is how JavaScript responds to user actions like clicks, key presses, and form submissions. Further reading: MDN Web Docs. Introduction to the DOM. MDN Web Docs. Locating DOM elements using selectors. MDN Web Docs. Manipulating documents. MDN Web Docs. Node, parent node, and other traversal properties. MDN Web Docs. Element, append, and other modification methods. Chapter 7. Event handling. Making pages interactive. In the previous chapter, you learned how JavaScript can select, manipulate, and even create elements in the document object model DOM. This allows you to dynamically change a web page's content and appearance. However, the true magic of interactivity happens when your pages can respond to user actions. This is where event handling comes in. An event is simply something that happens in the browser that JavaScript can detect and respond to. These can be user interactions, like a mouse click, a keyboard press, or a form submission, or browser-generated events, like a page loading, an image finishing download, or a video playing. When an event occurs, JavaScript provides a mechanism to run a specific piece of code in response. This piece of code is called an event handler or event listener. Imagine a button on a website. You click it. That's an event. The JavaScript code listening for that click event then executes, perhaps changing the text on the page or sending data to a server. Attaching event listeners. Add event listener. The modern and most recommended way to attach an event handler to an element is using the addEventListener method. Syntax: element add event listener, event, listener, options, element. The DOM element you want to listen for events on, e.g., a button, a div, the document, the window. Event: a string representing the type of event to listen for, e.g., click, mouse over, key down, submit. Listener: the function to be executed when the specified event occurs. This function is often called the event handler function or callback function. Options: optional. An object that specifies characteristics about the event listener, e.g., capture once passive. We'll primarily focus on the first two arguments for now. Common event types. There are many event types, but here are some of the most frequently used. Mouse events. Click, when an element is clicked. DBL click, when an element is double-clicked. Mouse over, when the mouse pointer moves over an element. Mouse out, when the mouse pointer moves off an element. Mouse down, when a mouse button is pressed down on an element. Mouse up, when a mouse button is released on an element. Keyboard events. Key down, when a key is pressed down. Key up, when a key is released. Key press. When a key sends a character to the screen deprecated, use key down or key up for most things. Form events. Submit. When a form is submitted. Change. When the value of an input, select, or text area element changes. Input. When the value of an input or text area element is changed, happens immediately as text is typed. Focus. When an element receives focus. Blur. When an element loses focus. Document window events. DOM content loaded. When the initial HTML document has been completely loaded and parsed without waiting for style sheets, images, and subframes to finish loading. Useful for ensuring your JavaScript runs after the page structure is ready. Load. When the entire page, including all elements, images, scripts, etc., has finished loading. Resize. When the browser window is resized. Scroll. When the user scrolls the document. Example, a simple click counter. Let's create a button that increments a counter every time it's clicked. Button ID equals click me btn, click me button. Pu click the button span ID equals click count 0/span times p. Script. Const click button equals document, get element by ID, click me btn. Const click count span equals document get element by ID, click count. Let count equals 0. Define the event handler function. Function handle click. Count plus plus. Increment the counter. Click count span, text content equals count. Update the display. Console log, button clicked. Attach the event listener. Click button add event listener, click handle click. Script. The event object. When an event occurs, the browser automatically creates an event object and passes it as an argument to your event handler function. This object contains useful information about the event that just happened. Common properties include event type, the type of event that occurred, e.g., click, event target, the DOM element that triggered the event. Event current target, the DOM element on which the event listener was attached. These can be different due to event bubbling, which we'll discuss next. Event client X, event client Y. The XY coordinates of the mouse pointer relative to the viewport. Event key, event.code, for keyboard events, which key was pressed. Event prevent default, a method to stop the browser's default behavior for a given event. Event stop propagation, a method to stop the event from continuing its journey through the DOM. Example, getting information from mouse click. Button ID equals info btn click for info button. Script. Const info button equals document get element by ID, info btn. Info button add event listener click. Event equals event is the event object. Console log event type. Event type, console log target element, event target, console log mouse X, event client X. Console log mouse Y, event client Y. Script. Preventing default actions, event prevent default. Some HTML elements have default behaviors. For example, clicking a link, A, navigates to the href URL. Submitting a form reloads the page. Right-clicking opens a context menu. You can prevent these default actions using event prevent default. This is particularly useful for single-page applications or custom form handling. Example, preventing form submission and page reload. Form ID equals my form. Input type equals text, placeholder equals name. Button type equals submit/button. Form. Script. Const my form equals document get element by ID my form. My format event listener submit. Event equals event prevent default. Stop the default form submission, which reloads the page. Console log, form submitted via JavaScript, prevented default reload. Here you would typically send the form data using JavaScript, e.g., via Fetch API in Chapter 14. A script. Event bubbling and capturing. When an event occurs on an element, like a click on a button, it doesn't just happen on that one element. It propagates through the DOM. This propagation occurs in two phases. Capturing phase. The event starts from the window object, travels down through the document root document, the HTML, body, and parent elements until it reaches the event target, the element that was actually clicked. Bubbling phase. After reaching the event target, the event then bubbles up from the target element, through its parent elements, all the way back up to the document and window. Most event listeners are set to trigger during the bubbling phase by default. You can change this behavior by setting the Use Capture option to True in Add Event Listener. Third argument, or using the capture. true option object. Example illustration. Consider a structure like div p button. If you click the button, capturing, window document HTML body div p button. Target button event registered here, bubbling. Button p div body HTML document window. Example, demonstrating bubbling. Div ID equals parent, style equals padding, 20px, background color. Light blue. Parent div. PID equals child, style equals padding, 15px, background color, light green. Child paragraph. Button ID equals grandchild, style equals padding, 10px, background color. Yellow. Grandchild button. Button. P. Div. Script. Const parent equals document get element by ID parent. Const child equals document get element by ID child. Const grandchild equals document get element by ID grandchild. Parent add event listener click equals console log parent div clicked. Child add event listener click equals console log child paragraph clicked. Grandchild add event listener click equals console log grandchild button clicked. Try uncommenting these to see capturing phase. Parent add event listener click equals console log parent capturing. Capture true. Child add event listener click equals console log child capturing. Capture true. Grandchild add event listener click equals console log grandchild capturing. Capture true. Script. When you click the grandchild button, you'll see this output due to bubbling. Grandchild button clicked, child paragraph clicked, parent div clicked, stopping propagation. Event stop propagation. Sometimes, you want an event to be handled by a specific element and prevent it from bubbling up to its ancestors or propagating further during capturing. Event stop propagation does exactly that. Example. Stopping the bubble. Div ID equals outer style equals height, 100px, width, 100px, background color, light coral. Outer div. Div ID equals inner style equals height, 50px, width, 50px. Background color, light green margin, 10px. Inner div. Div. Script. Document get element by ID outer, add event listener click, equals. Console log outer div clicked. Document get element by ID inner, add event listener click, event equals. Console log inner div clicked, event stop propagation, stop the event from bubbling up to outer. Script. Now, if you click the inner div, you'll only see inner div clicked in the console. The click event will not reach the outer div. Event delegation. Event bubbling is not just an interesting concept. It's a powerful pattern called event delegation. Instead of attaching individual event listeners to many child elements, you can attach a single event listener to a common parent element. When an event, like a click, occurs on a child, it bubbles up to the parent. The parent's listener can then identify which specific child triggered the event using event target. This is efficient for cases with many similar child elements, e.g., a long list of items. Dynamically added elements added after page load won't automatically have listeners if attached individually, but will participate in bubbling. Example. Event delegation for a list. ul ID equals my list. Li item 1 li. Li item 2 li. Li item 3 li. Ul. Button ID equals add item btn, add new item but. Script. Const my list equals document get element by ID my list. Const add item btn equals document get element by ID add item btn. Let item counter equals 3. Attach one listener to the parent ul. My list add event listener click, event equals. Check if the clicked element, event target, is in li. If event target tag name equals li. Tag name returns uppercase HTML tag name. Console log you clicked on. Event target text content, event target style background color equals light blue. Highlight clicked item. Function to add new items dynamically. Add item btn add event listener click equals. Item counter plus plus. Const new item document create element li. New item text content equals item counter. My list append child new item. Script. Now whether you click on item 1, item 2, item 3, or any new item X added dynamically, the single listener on my list will catch the event, identify the li that was clicked, and log its content. This is much more efficient than adding a separate listener to each li. Practical application. Building a dynamic shopping cart. Let's expand on our to-do list idea and imagine a shopping cart where you can add items, and each item can be removed individually. DOCTYP HTML. HTML lang equals n. Head. Meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Initial scale equals 1.0. Title dynamic shopping cart title. Style. Body font family. Sans serif max width 600px. Margin 20px auto. Padding 20px. Border 1px solid CCC. Border radius 8px. H1 text align. Center color 333. Item input width calc 100% 100px. Padding 8px. Margin right 10px. Border 1px solid DDD. Border radius 4px. Add item BTN padding 8px 15px. Background color 28A745. Color white. Border none. Border radius 4px. Cursor pointer. Add item BTN hover. Background color 218,838. Cart list style none. Padding 0. Margin top 20px. Cart list background color F0 F8FF. Border 1px solid CCF. Padding 10px. Margin bottom 5px. Display flex justify content space between align items. Center border radius 4px. Cart list button background color #DC 3545. Color white. Border none. Padding 5px 10px. Border radius 3px. Cursor pointer font size 0.8 em. Cart list button hover. Background color C82333. Style head. Body H1 my shopping cart H1. Div input type equals text. ID equals item input. Placeholder equals add an item to cart. Button ID equals add item BTN add to cart button. Div ul ID equals cart list. Cart items will be added here by JavaScript. Ul script const item input document get element by ID item input. Const add item BTN equals document get element by ID add item BTN. Const cart list equals document get element by ID cart list. Function add to cart. Const item name equals item input value trim. If item name equals alert please enter an item name. Return. Create new list item. Const list item equals document create element lie. List item text content equals item name. Create a remove button. Const remove BTN equals document create element button. Remove BTN text content equals remove. Attach specific click listener to this remove button. Remove BTN add event listener click function. This parent node refers to the element that contains this button. Or simply, list item remove, this parent node remove, append button to list item. List item append, remove BTN. Append list item to the cart list. Cart list append child, list item. Clear input. Item input value equals. Event listeners for adding items. Add item BTN add event listener click, add to cart. Item input add event listener key press. Event equals. If event key equals, enter. Add to cart. We could also use event delegation for remove buttons if there were many and they behaved uniformly. For example, if we clicked on the ul and checked if event target tag name equals button. But for clarity here, individual listeners are fine and common. Script, body, HTML. This dynamic shopping cart uses add event listener to react to button clicks and key presses. Each remove button also gets its own click listener that, when activated, removes its parent from the DOM, creating a fully interactive experience without reloading the page. Common pitfalls and troubleshooting. Forgetting in add event listener. If you right-click button add event listener, click handle click. Instead of click button add event listener, click handle click. The handle click function will run immediately when the page loads, because of the not when the button is clicked. You're passing the result of the function call, not the function itself. Event listener on null. If your element selection, e.g. document get element by ID my button, returns null because the element doesn't exist or hasn't loaded yet, calling add event listener on null will cause a type error. Always ensure your scripts run after the DOM is ready, e.g., placing them at the end of body or using a DOM content loaded listener. Not using ePreventDefault for forms links. When handling form submissions or custom link behavior, forgetting ePreventDefault will often result in the browser performing its default action, like reloading the page, undoing your JavaScript's work. Misunderstanding this in event listeners. The value of this inside an event listener can be tricky. With traditional function declarations, this typically refers to the element on which the listener is placed, event current target. With arrow functions, this retains the lexical this from its surrounding context, which is often the window object in global scope. In our remove btn example, this parent node remove works because this correctly refers to the remove btn. Often, using event target or event current target is a safer and clearer alternative. Summary: event handling is the essence of interactive web development. You've now gained crucial skills to understand what events are and how JavaScript detects them. Attach event listeners using the powerful addEventListener method. Utilize the event object to get detailed information about an event. Prevent default browser behaviors using EventPreventDefault. Comprehend event bubbling and capturing and how events propagate through the DOM. Implement the efficient event delegation pattern for managing many similar interactive elements. With the ability to manipulate the DOM and respond to user events, you can now build truly dynamic and engaging web applications. In the next chapter, we'll shift our focus to data structures, exploring how JavaScript handles collections of data like arrays and objects in more sophisticated ways. Further reading: MDN Web Docs, Introduction to Events, MDN Web Docs, Event Target addEventListener, MDN Web Docs, Event Object, MDN Web Docs, Event Bubbling and Capturing, External Resource, Excellent Explanation. Chapter 8, Data Structures, Mastering Arrays and Objects. So far, we've used variables to store single pieces of data like names, numbers, or true-false values. We've also learned to write functions to process these individual data points or to perform actions. However, real-world data rarely comes as isolated pieces. Instead, it often comes in collections: a list of user accounts, a catalog of products, or a configuration for a complex system. To handle these collections of related data efficiently, programming languages provide data structures. In JavaScript, the two most fundamental and widely used data structures are arrays and objects. Mastering them is essential for dealing with virtually any real-world data in your applications. Think of it this way: an array is like a neatly ordered row of lockers, each holding something. You know exactly which locker you want by its number, its position in the rows. An object is like a filing cabinet with labeled drawers. You open a drawer based on its label, its name, or key to find the specific file's data inside. Let's dive in. 1. Arrays, ordered collections. An array is a special type of object used to store an ordered list of values. Each value in an array is called an element, and each element has a numerical position or index starting from 0. Declaring arrays. You can declare an array using square brackets and listing its elements, separated by commas. Array of numbers. Const scores equals 90, 85, 70, 95, 80. Array of strings. Const fruits equals apple, banana, cherry, date. Array of mixed data types. JavaScript allows this, though often less common in practice. Const mixed hello, 123 true null name. Object. Empty array. Const empty array equals be accessing array elements. You access array elements using their index, placed in square brackets after the array variable name. Remember, indexing starts at 0. Const fruits equals apple, banana, cherry, date, console log fruits 0. Output, apple the first element. Console log fruits 1, output, banana. Console log fruits 3, output, date the fourth element at index 3. Console log fruits 4, output, undefined index 4 does not exist. See array length. The length property of an array returns the number of elements it contains. Const fruits equals apple, banana, cherry, console log fruits length, output 3. The index of the last element is always array length 1. Console log fruits length 1, output cherry. Modifying array elements. You can change an element's value by assigning a new value to a specific index. Const colors equals red, green, blue, colors1 equals yellow. Change the second element. Console log colors, output, red, yellow, blue. You can even add elements beyond the current length. It creates empty slots. Colors4 equals purple, console log colors, output, red, yellow, blue, empty, purple. Console log colors3, output, undefined. Common array methods. Arrays come with a rich set of built-in methods, functions that belong to the array object, that simplify common operations. Push adds one or more elements to the end of an array and returns the new length, modifies the original array. Const cities equals New York, London, cities push, Paris, Tokyo, console log cities, output. New York, London, Paris, Tokyo. Pop removes the last element from an array and returns that element, modifies the original array. Const cities equals New York, London, Paris. Const pop city equals cities pop, console log popped city, output, Paris. Console log cities, output, New York, London. Unshift adds one or more elements to the beginning of an array and returns the new length, modifies the original array. Const cities equals London, Paris, cities unshift, New York, console log cities, output, New York, London, Paris. Shift removes the first element from an array and returns that element, modifies the original array. Const cities equals New York, London, Paris, const shifted city equals cities shift, console log shifted city, output, New York. Console log cities, output, London, Paris. Index of returns the first index at which a given element can be found in the array, or if it is not present. Const colors equals red, green, blue, green. Console log colors dot index of green, output, 1. Console log colors dot index of purple, output. Includes checks if an array includes a certain value among its entries, returning true or false. Less common in older JS but very readable. Const colors equals red, green, blue, console log colors dot includes green, output, true. Console log colors dot includes yellow, output, false. Slice returns a shallow copy of a portion of an array into a new array. The original array is not modified. Array slice, start index, end index. End index is exclusive. If end index is omitted, slice extracts to the end of the array. Const animals equals ant, bison, camel, duck, elephant. Const new animals equals animals slice, 2, 4, from index 2 up to, but not including index 4. Console log new animals, output, camel, duck. Console log animals, original array unchanged, ant, bison, camel, duck, elephant. Const remaining equals animals slice 2, from index 2 to the end. Console log remaining, output camel, duck, elephant. Splice changes the contents of an array by removing or replacing existing elements and/or adding new elements in place. It returns an array containing the deleted elements. This method modifies the original array. Array splice, start index, delete count, item 1, item 2. Const months equals Jan, Feb, Mar, April, May. Remove one element at index 2, March. Const removed equals month splice 2, 1, console log removed, output, Mar. Console log months, output, Jan, Feb, April, May. Replace one element at index 1, Feb with March. Month splice 1, 1, March, console log months, output, Jan, March, April, May. Insert July and August at index 2, no deletion. Month splice 2, 0, July, August. Console log months, output, Jan, March, July, August, April, May. Concat, used to merge two or more arrays, returns a new array, leaving the original arrays unchanged. Const R112. Const R2 equals 3, 4. Const R3 equals 5, 6. Const merged equals R1.concat, R2, R3, console log merged, output, 1, 2, 3, 4, 5, 6. F. Higher order array methods, introduction. Modern JavaScript provides powerful higher order array methods that allow you to iterate, transform, and filter arrays in very elegant and expressive ways. These methods take functions as arguments callbacks. We'll cover them in detail in Chapter 13, for each, map, filter, reduce, but here's a brief introduction because you'll see them everywhere. For each executes a provided function once for each array element. It's for side effects, like logging. It doesn't return a new array. Const numbers equals 1, 2, 3, numbers for each, num equals. Console log num2, output 2, 4, 6, each on a new line. Map creates a new array populated with the results of calling a provided function on every element in the calling array. It's for transformation. Const numbers equals 1, 2, 3, const doubled numbers numbers map, num equals num2, console log doubled numbers, output 2, 4, 6. Filter creates a new array with all elements that pass the test implemented by the provided function. It's for selection. Const ages equals 12, 19, 25, 8. Const adults equals ages filter. Age equals 18, console log adults, output 19, 25. These methods are a cornerstone of modern JavaScript development and make working with arrays incredibly efficient. 2. Objects, key-value pairs. An object in JavaScript is a collection of unordered key-value pairs. Each key is a string or a symbol, and each value can be any data type, including other objects or functions. Objects are used to represent entities with properties. Analogy. Think of an object as a single row in a database table or a form that has fields like name, age, email, where the field names are the keys and what you type into them are the values. Declaring objects, object literals. The most common way to create an object is using object literal syntax with curly braces. Object representing a person. Const person equals first name, John, last name, Doe, age, 30, is student, false, hobbies, reading, hiking, coding, value can be an array. Address, value can be another object. Street, 123 Main Cent. City, any town. Empty object. Const empty object equals. Notice that keys are usually strings, often without quotes if they are valid JavaScript identifiers, like first name. If they contain spaces or special characters, they must be quoted, e.g., my key. Value, be accessing object properties. There are two main ways to access the value associated with a key, a property in an object. Dot notation, object key. This is the preferred method when the key is a valid JavaScript identifier and you know the key name directly. Console log person first name, output, John. Console log person age, output, 30. Console log person hobbies 0. Accessing an array element within the object. Console log person address city. Accessing a nested object property. Bracket notation, object key. This is required when the key contains spaces or special characters. The key name is stored in a variable dynamic access. Const car equals make Toyota, model Camry, number of doors, 4 key with spaces. Console log car number of doors, output 4. Const property name equals model, console log car property name, output Camry dynamic access. C. Modifying object properties. You can change the value of an existing property or add new properties to an object. Const person equals first name, John, last name, Doe, person age equals 31. Add a new property. Person last name equals Smith. Modify an existing property. Person email equals johnsmith@example.com. Add another new property. Console log person, output, first name, John, last name, Smith, age, 31, email, johnsmith@example.com. Deleting properties. You can remove a property, key-value pair, from an object using the delete operator. Const user equals name, Alice, age, 28, city, New York, delete user city, console log user, output, name, Alice, age, 28. A. Common object methods. JavaScript provides built-in methods on the global object constructor for common operations related to properties. Object keys, obj, returns an array of a given object's own enumerable property names keys. Const user equals name, Alice, age, 28, city, New York, console log object keys user, output, name, age, city. Object values, obj, returns an array of a given object's own enumerable property values. Const user equals name, Alice, age, 28, city, New York, console log object values user. Output Alice, 28, New York. Object entries, obj, returns an array of a given object's own enumerable string-keyed property key, value pairs, useful for looping. const user equals name, Alice, age, 28, for const key value of object entries, user, console log $key, value, output, name, Alice, age, 28. Note the for of loop here, which operates on arrays of arrays returned by object entries. We'll also cover key value syntax, called destructuring, in Chapter 10. 3. JSON, JavaScript Object Notation. JSON, JavaScript Object Notation, is a lightweight data interchange format that is easy for humans to read and write, and easy for machines to parse and generate. Despite its name, JSON is language independent, but it uses conventions that are familiar to programmers of JavaScript and many other languages. JSON is essentially a string representation of JavaScript objects and arrays. It's the most common format for sending data between a web server and a web application, e.g., when fetching data from an API. Key rules for JSON syntax. Data is in key value pairs. Keys must be strings enclosed in double quotes, e.g., name. Values can be strings, numbers, booleans, null, arrays, or other JSON objects. Values cannot be functions, undefined, or symbol values. Strings must use double quotes. A JSON stringify, converting JavaScript to JSON string. This method converts a JavaScript value, usually an object or array, into a JSON string. Const product equals id 1, name laptop, price 1200.00, available true, features lightweight, fast, portable. To convert the JavaScript object to a JSON string, const JSON string equals JSON stringify product, console log JSON string, output, ID 1 name, laptop, price 1200, available true, features, lightweight, fast, portable, console log typeof JSON string, output, string, B JSON parse, converting JSON string to JavaScript object. This method parses a JSON string, constructing the JavaScript value or object described by the string. Const JSON received equals username, dev user, is admin, false, last login, 2023 to 10 to 26 T10 00Z. Convert the JSON string back into a JavaScript object. Const user object equals JSON parse, JSON received, console log user object dot username, output, dev user, console log typeof user object, output, object. Practical application, managing a product catalog. Let's maintain a simple product catalog using an array of objects. An array of product objects. Const products equals id P001. Name, wireless mouse. Category, accessories. Price, 25.99. In stock, true. Id P002. Name, mechanical keyboard. Category, accessories. Price, 75.00. In stock, false. Id P003. Name, gaming headset. Category, audio. Price, 59.99. In stock, true. Id P004. Name, webcam 1080p. Category, peripherals. Price, 45.50. In stock, true. Function to display all products. Function display products, product list. Console log, \n product catalog, if product list length equals 0. Console log, no products available, return. Product list for each product, using for each for display. Console log ID, producted name, product.name price, $product price affixed to, in stock. Product.in stock, yes, no, console log. 1. Add a new product. Function add product, new product. Products push new product. Console log \n added new product.name to catalog. Display products, display updated catalog. 2. Find a product by ID. Function find product by ID, product ID. Using a for of loop for demonstration of finding. For const product of products, if producted equals producted, return product. Return null, product not found. 3. Update product stock status. Function update product stock, product ID, new stock status. Const product to update equals find product by ID, product ID. If product to update dot in stock equals new stock status. Modify property. Console log \n updated stock for $product to update dot name. to new stock status. Display products, else, console log \n product with ID, producted, not found. 4. Remove a product by ID. Function remove product by ID, product ID. Const index remove equals products find index, p equals pid equals producted. Find index new method. If index remove equals const remove products splice index to remove one, remove item. Console log \n removed product 0 name from catalog. Display products, else, console log \n product with ID, producted, not found for removal. Demonstrate operations. Display products, add product, id, P005. Name, USB-C hub. Category, accessories. Price, $39.99. In stock, true. Const found product find product by ID, P003. If found product, console log \n found product.name price, found product price. Update product stock, P002 true. Remove product by ID, P001. Convert entire product list to JSON for storage transmission. Const products JSON equals JSON stringify products. Console log \n products in JSON format. Console log products JSON. Simulate receiving JSON and parsing it back. Const parse products equals JSON parse, products JSON. Console log \n parsed products from JSON, first item. Console log parsed products 0. Name. This example beautifully demonstrates the power of combining arrays and objects to model complex data. We store individual products, objects, within a larger collection, an array. We use various array methods and object property access to manage this catalog. Common pitfalls and troubleshooting. Const and arrays objects. Remember from Chapter 2 that const prevents reassignment of the variable, but it does not prevent modification of the contents of an array or object. Accessing non-existent properties indexes. Attempting to access an object property that doesn't exist, e.g., person city, will return undefined, not an error. Similarly for array indexes, R10 on an array of length 5. This can lead to subtle bugs if not handled. Modifying original versus returning new. Be mindful whether an array method modifies the original array, push, pop, splice, shift, unshift, or returns a new array slice, concat, map, filter. This distinction is critical for avoiding unintended side effects in your code. JSON rules. Always double-check JSON syntax. Keys must be double-quoted strings and no functions or undefined values. Summary. Arrays and objects are the cornerstones of data management in JavaScript. You now have a solid understanding of arrays for ordered collections, including their declaration, accessing elements by index, and many common methods for manipulation. Objects for unordered key-value pairs, including their declaration, accessing properties, dot and bracket notation, and common methods for iterating over keys values. JSON as the standard format for representing JavaScript-like data strings, and how to convert between JavaScript values and JSON strings using JSON stringify and JSON parse. You're now equipped to structure and manage complex data within your JavaScript applications, taking a significant step towards real-world development. In the next part of our journey, we'll dive into more advanced JavaScript concepts, starting with the often misunderstood this keyword and the fascinating world of prototypes. Further reading, MDN Web Docs, array. MDN Web Docs, object. MDN Web Docs, JSON. MDN Web Docs, working with objects. Chapter 9, Diving Deep. This keyword and prototypes. You've built a strong foundation in JavaScript, from basic syntax and logic to DOM manipulation and handling data with arrays and objects. Now, it's time to tackle two concepts that are central to JavaScript's object-oriented nature and often a source of confusion for newcomers. This keyword and prototypes. Understanding these will deepen your grasp of how JavaScript truly works under the hood. This keyword. Who am I? This keyword in JavaScript is perhaps one of its most misunderstood features. Its value is not fixed. Rather, it depends entirely on how a function is called, not where it is defined. This dynamic nature means this can refer to different objects in different contexts. Think of this as a self-referential pronoun. Just like I or me changes meaning depending on who is speaking, this changes depending on the context of the function call. Let's break down the most common scenarios. A. Global context, loose mode. When this is used outside of any function, in the global execution context, it refers to the global object. In a web browser, the global object is window. Console log this equals window. Output, true in a browser environment. Console log this, output, window object details. B function context, simple function call. When a regular function is called directly, not as a method on an object. This typically refers to the global object, window in browsers, in non-strict mode. In strict mode, use strict. This will be undefined in this scenario, which is generally a safer behavior. Function greet. Console log, this equals window. True in non-strict browser mode. Console log, hello from this .name, the global object. This .name is undefined, so defaults to the string. Greet, output, hello from the global object. Use strict. Uncomment this at the top of your script for strict mode. Function greet strict. Console log this, output, undefined. Greet strict, C. Method context, function as an object property. When a function is called as a method of an object, i.e., object method, this refers to the object that owns the method. Const person equals. Name, Alice. Age, 30. Say hello. Function. Console log, hello, my name is this .name, and I am this age, years old. Person say hello. Output, hello, my name is Alice, and I am 30 years old. Const another person equals. Name, Bob. A, 25. Say hello, person say hello, borrowing the method. Another person say hello. Output, hello, my name is Bob, and I am 25 years old. This refers to another person here. This is the most common and intuitive case for this. Deconstructor context, function called with new. When a function is used as a constructor with the new keyword, e.g., new function name, this refers to the newly created instance of the object. Function person, name, age. This .name equals name. This refers to the new object being created. This age equals age. This greet equals function. Console log, hi, I'm this .name. Const Alice equals new person. Alice, 30. Console log Alice .name. Output, Alice. Alice greet, output, hi, I'm Alice. Const Bob equals new person. Bob, 25. Bob greet. Output. Hi, I'm Bob. We'll discuss constructor functions more when we delve into prototypes. Explicit binding, call, apply, bind. JavaScript provides methods to explicitly control what this refers to when a function is invoked. These are methods of function.prototype. Call, this arg, arg1, arg2, invokes the function with a specified this value and arguments provided individually. Function introduce, job city. Console log, my name is this .name, I am a job from city. Const user equals name, Charlie, introduce .call user developer, New York. Output, my name is Charlie, I am a developer from New York. Apply, this args array, similar to call, but arguments are provided as an array. Const user equals name, Diana, introduce apply, user designer, London. Output, my name is Diana, I am a designer from London. The key difference between call and apply is how they handle arguments. Call takes them comma-separated, apply takes them in an array. Bind, this arg1, arg2, returns a new function, a bound function, with the this context permanently bound to the specified this arg. It doesn't invoke the function immediately. Const user equals name, Eve. Const introduce user equals introduce bind, user, engineer. Engineer is a partially applied argument. Introduce user, San Francisco, only need to provide the city argument now. Output, my name is Eve, I am an engineer from San Francisco. Bind is particularly useful in event handling or when passing functions as callbacks, where you need to preserve the original this context. Example, event handling with bind. Button ID equals, my button click me button. Script, const app equals, message button was clicked. Handle click function. Console log this message. This refers to app if bound correctly. Const btn equals document get element by ID my button. If we did btn add event listener, click app handle click. This inside handle click would be the button itself, not app. To fix this, bind this to app, btn add event listener click, app handle click bind app. Now when the button is clicked, this inside handle click will correctly refer to app. Script. F. Arrow functions and this. Arrow functions, introduced in E6, handle this differently than traditional functions. They do not have their own this binding. Instead, this inside an arrow function is lexically scoped. It refers to this of the enclosing outer scope. This behavior is often desirable, especially in callbacks. Const person equals. Name, Frank. Traditional say hello, function. This here refers to person. Set timeout function. This here refers to window, or undefined in strict mode. It does not refer to person, unless explicitly bound or using arrow function. Console log traditional. Hello, my name is this dot name, 1000. Arrow say hello, function. This here refers to person. Set timeout equals. This here also refers to person, lexically bound. Console log arrow. Hello, my name is this dot name, 1000. Person traditional say hello. Output after ones, traditional, hello, my name is. Person arrow say hello. Output after ones, arrow. Hello, my name is Frank. Because arrow functions automatically handle this binding lexically, they eliminate many common this-related bugs and reduce the need for bind, call, or apply in certain scenarios. Summary of this. The value of this is determined by how the function is called. Global context, window, browser, or global Node.js. Method call e.g. obj method, obj. Constructor call e.g. new function, the new instance. Explicit binding call, apply, bind, whichever object you pass as the first argument. Arrow functions, lexically inherited from the surrounding scope. 2 prototypes. The foundation of inheritance. JavaScript is often described as a prototype-based, object-oriented language, rather than a class-based one like Java or C++. This means that instead of defining classes from which objects are instantiated, objects inherit properties and methods directly from other objects, their prototypes. Every JavaScript object has an internal prototype, property, accessible via object.proto in most browsers, though object-get-prototype-of is the standard way. This prototype points to another object, which is its prototype. When you try to access a property or method on an object, if it's not found on the object itself, JavaScript looks up the prototype chain until the property is found or the chain ends at null. The prototype chain. Imagine a simple object, const user equals. Name, Grace. Age, 28. Console log user to string, output, object. Where did to string come from? It's not defined directly on user. JavaScript looks for to string on user, not found. It then looks at user's prototype. The default prototype for plain objects created with is object.prototype. ToString is found on object.prototype, so object.prototype ToString is called. The prototype chain continues until object.prototype whose prototype is null. B. Constructor functions and new keyword. Before E6 classes, constructor functions were the primary way to create multiple instances of similar objects. A constructor function is just a regular function, but it's intended to be called with the new keyword. When you call a function with new, a new empty object is created. The this keyword in the constructor function points to this new object. The new object's prototype is automatically set to the constructor function's prototype property. The function executes, modifying the new this object. If the function doesn't explicitly return an object, the new object, is returned. Function dog name breed. This dot name equals name. This dot breed equals breed. Add a method to the dog's prototype. Dog.prototype bark equals function. Console log $this dot name, this dot breed barks. Add a property to the dog's prototype. Dog.prototype species, Canis familiaris. Const max equals new dog, max, golden retriever. Const buddy equals new dog, buddy, Labrador, max bark. Output max golden retriever barks, buddy bark. Output buddy Labrador barks. Console log max species, output Canis familiaris. Console log buddy species, output Canis familiaris. Check if a property belongs directly to the object or its prototype. Console log, Max's own property name. Output true, name is on Max itself. Console log, Max's own property bark. Output false, bark is on the prototype. In this example, bark and species are defined once on dog.prototype. Both Max and Buddy instances of dog inherit these methods and properties via the prototype chain. This is memory efficient because the bark function doesn't need to be created for every single dog object. See Ease 6 classes. Syntactic sugar for prototypes. Ease 6 introduced the class keyword, which provides a cleaner, more familiar syntax for creating objects and dealing with inheritance. However, it's just syntactic sugar over JavaScript's existing prototype-based inheritance model. Underneath, it's still using constructor functions and prototypes. Class animal. Constructor name. This .name equals name. Speak. Console log, $this.name makes a noise. Class dog extends animal. Extends handles prototype chain inheritance. Constructor name breed. Super name. Call the parent constructor, animal's constructor. This .breed equals breed. Override parent method. Speak. Console log $this.name, $this.breed, barks. New method specific to dog. Fetch. Console log $this.name fetches the ball. Const bingo equals new dog, bingo, beagle, bingo speak. Output bingo a beagle barks. Dog speak method. Bingo fetch. Output bingo fetches the ball. Const generic animal equals new animal, lion, generic animal speak. Output lion makes a noise. Animals speak method. Generic animal fetch. Error. Generic animal fetch is not a function. Key points about Ease 6 classes. Constructor method. This special method is called when an object is created with new. It's where you initialize properties specific to each instance. Extends keyword. Used to create a subclass, like dog, that inherits from a superclass, like animal. This sets up the prototype chain automatically. Super. Used within a subclass's constructor to call the superclass's constructor. It must be called before using this in the subclass's constructor. Methods defined directly inside the class body, like speak, fetch, are automatically added to the prototype of the class, making them shared among all instances. While classes use familiar class and extends keywords, remember they don't introduce a new object model. They provide a more convenient and structured way to work with the underlying prototype system. Practical application. Modeling a digital library with classes. Let's use classes to model books and a library collection, demonstrating both this and prototypes via classes. Class book. Constructor, title, author, ISBN. This title equals title. This author equals author. This ISBN equals ISBN. This is available equals true. Default availability. Method to check out a book. Checkouts. If this is available equals false. Console log $this title by this author has been checked out. Return true. Else. Console log $this title is currently unavailable. Return false. Method to return a book. Return book. If this is available equals true. Console log $this title by this author has been returned. Return true. Else. Console log $this title was already available. Return false. Static method. Belongs to the class itself, not instances. Static getBookInfo book. If book instancy off book, check if it's an instance of book. Return title, book title author, book author ISBN. Book ISBN available, book is available, yes, no. Return not a valid book object. Class library. Constructor name. This .name equals name, this books equals. Array to store book objects. Add books book. If book instancy off book, check for unique ISBN. Const exists equals this book sum. B equals BISBN equals book ISBN. Array sum. If exists. This books bush book, console log added book title to this .name library. Else. Console log $book title. ISBN, book ISBN already exists in this .name. Else. Console log. Only book objects can be added to the library. Find book by ISBN, ISBN. Return this book's find. Book equals book ISBN equals ISBN. Array find. List all books. Console log \n books in this .name library, this book's length total, this books for each book equals. Console log book get book info book, using the static method. Console log use const my library equals new library, city central library. Const book 1 equals new book, the JavaScript way. Christian Heilman, 978 to 1,234,567,890. Const book 2 equals new book, eloquent JavaScript. Marian Haverbeck, 978 to 123,456,789. Const book 3 equals new book. You don't know JS yet. Kyle Simpson, 978 to 987,654,321. My library add book, book 1. My library add book, book 2. My library add book, book 3. My library list all books. Demonstrate checkout return using this in book methods. Book 1 checkout, my library list all books. See book 1's status change. Book 1 checkout. Try checking out again. Book 1 return book, my library list all books. Demonstrate finding a book. Const found equals my library find book by ISBN. 978 to 123,456,789. If found, console log \n found title, else, console log \n book not found. Demonstrate static method. Console log book get book info book 2. Console log book 2 get book info book 2. Error, get book info is not a function, it's static. This example showcases classes book, library as blueprints for objects. Constructor method for initializing instance properties, this title, this books. Instance methods, checkout, return book, add book, find book by ISBN, list all books, where this refers to the specific book or library instance. A static method, book get book info, which belongs to the book class itself, not its instances. Common pitfalls and troubleshooting. Misunderstanding this, the most common hurdle. Always trace how the function was called. If in doubt, use console, log this inside the function to see what it refers to. Use bind or arrow functions to explicitly control this where needed. Forgetting new with constructor functions classes. If you call a constructor function or class without new, e.g., person, Alice, 30, instead of new person, Alice, 30, this will refer to the global object window in browsers, potentially polluting the global namespace and not creating the intended object. Modifying object.prototype/array.prototype directly. While it's possible to add methods properties directly to built-in prototypes, it's highly discouraged, patching native prototypes, as it can lead to conflicts and unexpected behavior in complex applications or with third-party libraries. Super in subclass constructors. Forgetting super in a subclass constructor or trying to use this before super will lead to errors. Summary. You've ventured into more complex and powerful aspects of JavaScript. You now have a deep understanding of this keyword and its varying context based on how a function is called: global, method, constructor, explicit binding. You understand the special behavior of this within arrow functions, lexical scoping. You've grasped prototypes as JavaScript's fundamental mechanism for inheritance and property lookup through the prototype chain. You've learned how constructor functions are used with new to create new instances. You recognize ES6 class syntax as a convenient, modern way to work with prototypes, making inheritance more readable and structured. Mastering this and prototypes is a key milestone in truly understanding JavaScript's object model and writing more sophisticated, object-oriented code. In the next chapter, we'll continue our exploration of modern JavaScript by looking at other key features introduced alongside classes in ES6 and beyond. Further reading, MDN Web Docs, this. MDN Web Docs, Inheritance and the Prototype Chain. MDN Web Docs, Classes. You don't know JS yet? Objects and Classes by Kyle Simpson, specifically the sections on this and prototypes for an even deeper dive. Chapter 10. ES 2015 Plus and Beyond. Modern JavaScript Essentials. JavaScript is a living language, constantly evolving. Every year, new features and improvements are added to the ECMAScript standard, which JavaScript implements. The release of ES 2015, also known as ES6, was a monumental update, bringing a wealth of features that fundamentally changed how modern JavaScript is written. Subsequent yearly releases, EASE 2016, EASE 2017, EASE 2018, etc., have continued to refine and expand the language. In this chapter, we'll explore some of the most impactful and commonly used features from EASE 2015 and later versions. These additions make JavaScript code more readable, concise, and powerful. If you're coming from older JavaScript codebases, these will feel like a breath of fresh air. If you're new to JavaScript, you're already learning the best practices from the start. Context. Many of these concepts were briefly touched upon or hinted at in earlier chapters, like let const, arrow functions, for, of loops and classes, because they are now standard practice. This chapter consolidates and elaborates on them alongside other crucial modern features. 1. Template literals, template strings. Before EASE 6, concatenating strings with variables was cumbersome, especially for multi-line strings. Template literals provide a much cleaner syntax using backticks instead of single or double quotes. They allow for both multi-line strings and easy variable interpolation. A. Multi-line strings. No more \n or string concatenation across lines. Just type your string across multiple lines. Before EASE 6. Const old multiline equals, this is a string \n plus. That spans multiple lines, \n plus. It's a bit rigid. Console log old multiline, with template literals. Const new multiline, this is a string. That spans multiple lines. With template literals, it's much easier. Console log new multiline, be expression interpolation. You can embed expressions, variables, function calls, arithmetic operations, etc. directly within the string using expression. Const name Alice, const age equals 30. Before EASE 6. Const old greeting, hello, my name is plus name plus, and I am plus age plus years old. Console log old greeting. With template literals, interpolation. Const new greeting equals hello, my name is name and I am age years old. Console log new greeting, you can embed any expression. Const price equals 100. Const tax rate equals 0.05, 5%. Const final message equals the item cost's price. With tax rate 100% tax, the total is $. Price 1 plus tax rate, to fixed 2. Console log final message, output. The item costs $100. With 5% tax, the total is $105. Template literals make constructing dynamic strings much more readable and less prone to errors. 2. Destructuring assignment. Destructuring assignment is a powerful feature that allows you to unpack values from arrays or properties from objects into distinct variables. It offers a very concise way to extract data. A. Array destructuring. Extract values from arrays based on their position. Const RGB 255, 128, 0. Const red, green, blue equals RGB. Unpack values into new variables. Console log red, output, 255. Console log green, output, 128. Console log blue, output, 0. You can skip values. Const third fruit equals apple, banana, cherry. Console log third fruit, output, cherry. Swap variables without a temporary variable. Let A equals 1. Let B equals 2. A B equals B, A console log A B B, output, A2 B, 1. B object destructuring. Extract properties from objects based on their property names. Const user equals username, coder123. Email, coder@example.com. Is active, true. Const username email equals user. Extract username and email properties. Console log username, output, coder123. Console log email, output, coder@example.com. You can rename variables during destructuring. Const username. Username alias is active equals user. Console log username alias, output, coder123. Console log is active, output, true. You can set default values if a property doesn't exist. Const city equals unknown, username, user alias equals user. Console log city, output. Unknown, city doesn't exist in user object. Console log user alias, output, coder123. See destructuring in function parameters. This is extremely useful when a function expects an object of options. Function traditionally accepting an options object. Function display user info options. Console log name options.name age options age city options city. Display user info name Bob age 25 city London. Function using object destructuring and parameters. Function display user info destructured. Name age city equals unknown. Console log name age city city. Display user info destructured. Name Bob age 25 city defaults to unknown. Destructuring makes code that works with complex data structures much cleaner and easier to read, as you immediately see which properties are being extracted and used. 3 spread and rest operators. The 3 dots are a versatile syntax that can be used as both a spread operator and a rest parameter, depending on the context. A spread operator. When used in an array literal, object literal, or function call, the spread operator expands an iterable, like an array, or an object into its individual elements or properties. Copying arrays objects. Creates a shallow copy, useful for modifying collections without altering the original. Const original array equals 1, 2, 3, const copied array equals original array. Creates a new array with elements from original array. Console log copied array, output, 1, 2, 3. Console log copied array equals original array. Output, false, they are different arrays. Const original object equals a, 1, b, 2, const copied object equals original object, creates a new object with properties from original object. Console log copied object. Output a1 b2. Combining arrays objects. Const r1 const r2 equals 3 4, const combined array equals r1 r2 5, console log combined array. Output 1 2 3 4 5. Const obj1 equals name Alice age 30, const obj2 equals city New York occupation engineer. Const combined object equals obj1 obj2 hobbies reading. Console log combined object. Output name Alice age 30 city New York occupation engineer hobbies reading. Note, for objects if there are duplicate keys the last one wins. Passing arguments to functions function calls. Function sum x y z. Return x plus y plus z. Const numbers equals 1 2 3. Console log sum numbers spreads the array elements as individual arguments. Output 6. B rest parameters. When used in a function definition's parameters, the rest operator collects an indefinite number of arguments into an array. It must be the last parameter in the function definition. Function greet people greeting ... names. Names collects all remaining arguments into an array. Names for each name equals console log $greeting name greet people hello Alice Bob Charlie. Output hello Alice hello Bob hello Charlie. The arguments object older way versus rest parameters. The arguments object is an array-like object available inside functions. Rest parameters are preferred because they are actual arrays, have methods, and are clearer. Function oldsum let total equals 0. For let I equals 0, I arguments length I++. Total plus equals argument psi. Return total. Console log oldsum 1 2 3 4. Output 10. Function newsum nums. In nums is a real array. Return nums reduce. Total num equals total plus num 0. Using reduce from chapter 8. Console log newsum 1 2 3 4. Output 10. 4 default parameters for functions. Default parameters allow you to provide default values for function parameters if no value, or undefined, is provided when the function is called. This simplifies function signatures and makes them more robust. Syntax. Function name, param1 equals default value 1, param2 equals default value 2. Without default parameters, older way. Function greet name. Name equals name guest. Common pattern before default parameters. Console log hello, name. Greet David, output hello David, greet, output hello guest. With default parameters. Function greet modern name equals guest. Console log hello, name. Greet modern Emily, output hello Emily, greet modern, output hello guest. multiple default parameters. Function create message, sender equals system, message equals no message provided. Console log $sender, message, create message output, system, no message provided. Create message, user hi there. Output, user hi there, create message undefined, just saying hi. Output, system, just saying hi, 5. Enhanced object literals. Ease 6 introduced several enhancements to object literal syntax that make defining objects more convenient and less verbose. A property shorthand. If a variable name is the same as the object property key you want to create, you can just list the variable name. Const name, Alice. Const age equals 30. Before ease 6. Const person old. Name, name. Age, age. With property shorthand. Const person new. Name equivalent to name, name. Age equivalent to age, a. Console log person new, output, name, Alice age 30. B method shorthand. When defining a method on an object, you no longer need the function keyword. Before ease 6. Const calculator old equals. Add function AB. Return a plus B. With method shorthand. Const calculator new. Add AB, a no function keyword. Return a plus B. Subtract AB, another method. Return a B. Console log calculator new add 53, output, 8. See computed property names. Allows you to use an expression, like a variable or function call, to define a property name in an object literal. Const dynamic key department. Const userid equals 101. Const employee. Id, userid. Name, John Doe. Dynamic key. Sales, the value of dynamic key string department, becomes the key. User $user ID status. Active, another example with interpolation. Console log employee.department, output. Sales, console log employee user 101 status, output, active. Practical application, processing user data. Let's imagine we receive some raw user data and want to process it into a more structured format. Applying some modern JavaScript features. Simulate raw user data might come from an API. Const raw user data equals id 1 first, Alice last, Smith role, admin status, online. Id 2 first, Bobby last, Johnson status, offline, missing role. Id 3 first, Charlie last, Brown role, editor status, online. I1. Process each user into a standardized format. Function process users data. Return users data map, user equals. Use object destructuring to extract relevant properties. Use default parameter for role if it's missing. Const id first last, role equals viewer, status equals user. Use template literals for full name. Const full name equals first, last. Use enhanced object literal for the new user object. Property shorthand, id status. Method shorthand, greet. Return, id, full name, role, status, greet. Console log hello, I'm this full name playing the role of this role. Const processed users equals process users, raw user data, console log, \n processed users. Processed users for each, user equals console log user. 2. Filter online users, using array filter method. Const online admins processed users filter. User equals user status equals online, and end user role equals admin. Console log, \n online admins for each admin equals admin greet. Using the new greet method. Output, hello, I'm Alice Smith playing the role of admin. 3. Demonstrate spread operator for combining modifying. Const new user data equals id, 4 first, Diana last, Miller role, moderator status, online. Const updated users equals, raw user data, new user data, create new array with spread. Console log, \n updated raw users with new entry. Updated users for each, user equals console log, user first. 4. Demonstrate REST parameters for flexible function calls. Function log user activities, user ID, activities. If activities length equals 0. Console log, userid, has no recorded activities. Return, console log, \n activities for userid. Activities for each, activity index equals console log $index +1. Activity. Log user activities, 101, logged in, viewed dashboard, posted a comment. Log user activities, 102, no activities. This example shows how combining modern JavaScript features leads to code that is more concise, easier to read, and more robust. Common pitfalls and troubleshooting. Browser compatibility. While modern browsers support most EASE 2015 plus features, older browsers, like Internet Explorer, do not. For production environments targeting a wide range of users, you might need a transpiler, like Babel, to convert your modern JavaScript back into older, compatible JavaScript. However, for learning, practicing, and most modern web development, direct use is fine. Overuse of destructuring. While powerful, excessive, or deeply nested destructuring can sometimes make code less readable if not done carefully. Find a balance. Shallow versus deep copy with spread. Remember, the spread operator creates a shallow copy. Nested objects or arrays within the copied collection will still refer to the same underlying objects. Modifying those nested objects will affect both the original and the copied collection. For deep copies, you'd need more advanced techniques, e.g., libraries or JSON parse, JSON stringify, ob, but with caveats. Summary: you've now been introduced to the essential features of modern JavaScript, EASE 2015 plus and beyond, that are prevalent in almost all contemporary projects. Template literals for easy multi-line strings and variable interpolation. Destructuring assignment to concisely unpack values from arrays and properties from objects. The versatile spread and rest, operators for expanding iterables and collecting arguments. Default parameters for providing fallbacks in function arguments. Enhanced object literals for more concise object definition. These features drastically improve developer experience, code readability, and expressiveness. By adopting them, you're writing JavaScript in the modern way. In the next chapter, we'll shift our focus to asynchronous JavaScript, a critical topic for handling operations that take time, like fetching data from a server without freezing your web page. Further reading. MDN Web Docs Guide. JavaScript Technologies Overview covers EASE features. MDN Web Docs, Template Literals. MDN Web Docs, Destructuring Assignment. MDN Web Docs, Spread Syntax. MDN Web Docs, REST Parameters. MDN Web Docs, Default Parameters. Chapter 11, The Art of Waiting. Asynchronous JavaScript with callbacks and promises. Up until now, most of the JavaScript code we've written has been synchronous. This means that code executes line by line, one after the other. Each operation must complete before the next one starts. Console log, start, first. Console log, middle. Second executes after start finishes. Console log, end. Third executes after middle finishes. While this is straightforward, it presents a major problem for operations that take a significant amount of time, like fetching data from a server, e.g., retrieving user profiles or product lists. This involves a network request, which can take milliseconds or even seconds depending on network conditions. Reading or writing files in Node.js environments. Performing complex calculations. Waiting for user input, like a mouse click. If JavaScript were strictly synchronous, your web page would freeze, become unresponsive, for the duration of these long-running operations. The browser wouldn't be able to update the UI, respond to clicks, or even scroll. This provides a terrible user experience. This is why JavaScript needs asynchronous programming. Asynchronous operations allow your program to initiate a long-running task and then continue executing other code without waiting for that task to complete. When the long-running task eventually finishes, it signals its completion, and a predefined function, a callback, is executed. Think of it like ordering food at a restaurant. Synchronous, you order, and the waiter stands there, waiting until your food is cooked and served before moving on to the next customer. The kitchen stops everything else until your order is done. Inefficient. Asynchronous, you order, the waiter takes your order to the kitchen, and then goes to serve other tables or take other orders. When your food is ready, either the waiter or someone else brings it to you. You placed your order, and while waiting, you could do other things like talk to your companions or check your phone. Efficient. Let's explore the evolution of asynchronous JavaScript, from callbacks to the much improved promises. 1. Callbacks the traditional way. Callbacks are functions that are passed as arguments to other functions and are executed later, when a particular event occurs or an asynchronous operation completes. They were the primary way to handle asynchronicity in JavaScript for a long time. Example, set timeout. The set timeout function is a common way to demonstrate asynchronicity. It executes a function, its first argument after a specified delay, its second argument in milliseconds. Console log order placed. Set timeout function. This is the callback function. Console log, your food is ready. 2000, wait for 2000 milliseconds, 2 seconds. Console log, waiting for food. Output, order placed, waiting for food, 2 seconds later. Your food is ready. Notice that waiting for food is logged before your food is ready. The set timeout function initiates the timer and immediately returns, allowing the rest of the code to execute. The problem with callbacks. Callback hell, pyramid of doom. While callbacks work for simple scenarios, they quickly become unmanageable when you have a sequence of asynchronous operations that depend on each other. Each nested asynchronous call indents the code further, creating a pyramid-like structure that is hard to read, debug, and maintain. This is famously known as callback hell or the pyramid of doom. Example, simulating sequential database operations with callbacks. Function getUser, ID callback. Console log fetching user with ID, id, set timeout, equals. Const user equals id name, Alice. Callback user, pass the user data to the next step. 1000. Function getPosts, user ID callback. Console log fetching posts for userid, set timeout, equals. Const posts equals id. 101 title, post 1, id 102 title, post 2, callback posts, 1000. Function display data, user posts callback. Console log, displaying data for user.name. Set timeout, equals. Console log user.name posts, posts length, callback, 500. Callback hell in action, get user, 1 function user. Get posts, user ID function posts. Display data, user posts function. Console log, all data displayed. What if we need another async operation here? More nesting. Output will happen sequentially with delays, but the code structure is messy. To mitigate callback hell and provide a more structured approach to asynchronous programming, JavaScript introduced promises. 2. Promises, a brighter future for asynchronicity. A promise is an object representing the eventual completion or failure of an asynchronous operation. It acts as a placeholder for a value that is currently unknown but will become available in the future. A promise can be in one of 3 states: pending, initial state, neither fulfilled nor rejected. The asynchronous operation is still in progress. Fulfilled or resolved, the operation completed successfully and the promise has a resulting value. Rejected, the operation failed and the promise has a reason for the failure and error. Once a promise is fulfilled or rejected, it is said to be settled. A settled promise cannot change its state again. A. Creating a promise. You create a promise using the new promise constructor, which takes a function called the executor as an argument. The executor function itself takes 2 arguments. Resolve, a function that you call when the asynchronous operation succeeds. Reject, a function that you call when the asynchronous operation fails. Const myPromise equals new promise, resolve, reject equals. Simulate an asynchronous operation, e.g., fetching data. Const success equals true. Let's say our operation succeeds. Set timeout equals. If success, resolve, data successfully fetched, call resolve on success. Else, reject, failed to fetch data. Call reject on failure. 1500, be consuming a promise, then catch, finally. Promises come with methods to handle their eventual state. Then, onFulfilled, onRejected, onFulfilled. A function that runs if the promise is fulfilled. It receives the resolved value. OnRejected, an optional function that runs if the promise is rejected. It receives the rejection reason. MyPromise, then. Data equals. Console log, success, data, runs if promise resolves. Error equals. Console log, error, runs if promise rejects. Based on the success equals true in the example above, this will output. Success, data successfully fetched, catch on rejected, a more readable way to handle rejections. It's simply syntactic sugar for then null on rejected, my promise. Then data equals console log success data, catch error equals console error, caught an error, error, runs if promise rejects. It's generally recommended to use catch at the end of a promise chain for centralized error handling. Finally, on finally, executes a callback when the promise is settled, either fulfilled or rejected. It doesn't receive any arguments and is useful for cleanup operations. My promise. Then data equals console log operation successful data, catch error equals console error operation failed error. Finally equals console log promise settled either successful or failed, e.g. hide a loading spinner, close a connection. See chaining promises. The true power of promises becomes apparent when dealing with sequences of asynchronous operations. Instead of nesting, you can chain then calls. Each then returns a new promise, allowing you to sequence operations. If you return a value from a then handler, that value becomes the resolution of the next promise in the chain. If you return another promise from a then handler, that promise is unwrapped, and its resolution or rejection determines the status of the next promise in the chain. This is crucial for avoiding callback hell. Example: reimagining the callback hell example with promises. Function getUserPromise, id. Return new promise, resolve equals console log promise fetching user with id, id. Set timeout equals const user equals id name, Alice resolve user, 1000. Function getPosts promise, user id. Return new promise, resolve equals console log promise fetching posts for user userid. Set timeout equals const posts equals id 101 title post 1 id 102 title post 2 resolve posts 1000. Function display data promise user posts. Return new promise resolve equals console log promise displaying data for user.name. Set timeout equals console log promise user.name posts. Posts length resolve display complete indicate completion. 500. Promise chain in action get user promise 1. Then user equals user is the resolved value from get user promise. Console log chain got user.name return get posts promise user id return another promise. Then posts equals posts is the resolved value from get posts promise. Const user equals id 1 name Alice. Recreate user for display data promise since it wasn't passed down, or pass both user and posts in previous then. Console log chain got posts length return display data promise user posts return another promise. Then status equals status is the resolved value from display data promise. Console log chain final status console log chain all operations complete. Catch error equals this catch will handle any rejection in the entire chain. Console error chain an error occurred in the chain error. This is significantly cleaner than nested callbacks. Each then represents a step in the asynchronous workflow, depromise all and promise race. Sometimes you have multiple independent promises that you want to run concurrently. Promise all iterable takes an iterable, like an array of promises, as input. It returns a single promise that resolves when all of the input promises have resolved. The resolved value is an array containing the resolved values of the input promises in the same order as the input. Rejects as soon as any of the input promises reject. The rejected value is the reason of the first promise that rejected. Const p1 equals new promise, resolve equals set timeout, equals resolve p1 resolved, 1000. Const p2 equals new promise, resolve equals set timeout, equals resolve p2 resolved, 500. Const p3 equals new promise, resolve reject equals set timeout, equals reject p3 rejected, 1200. Promise all p1 p2. Then results equals console log all resolved. Results, output, p1 resolved, p2 resolved, after ones. Catch error equals console error, 1 failed, error. Not triggered here. Promise all p1, p3. P3 will reject first, 1.2's ones, then p1. Then results equals console log, all resolved should not see, results. Catch error equals console error, 1 failed, error. Output 1 failed, P3 rejected. Promise all is great for fetching multiple pieces of data independently and then processing them together once all are available. Promise race, iterable, takes an iterable of promises. It returns a single promise that resolves or rejects as soon as any of the input promises resolves or rejects, with the value or reason from that first promise. Const PA equals new promise, resolve equals set timeout, equals resolve A, 100, wins resolution. Const PB equals new promise, resolve equals set timeout, resolve B, 50, wins resolution. Const PC equals new promise, resolve reject equals set timeout, equals reject C rejected, 10, wins rejection. Promise race, PA, PB. Then result equals console log race winner, result, output. Race winner, B, after 50 ms. Catch error equals console error race loser, error. Promise race, PA, PC. Then result equals console log race winner should not see, result. Catch error equals console error race loser, error. Output race loser, C rejected after 10 ms. Promise race is useful when you want to act on the first result available. For instance, a timeout on a network request, return data or mark as timed out. Practical application, fetching data from a public API. A common asynchronous task in web development is fetching data from an API, application programming interface. While we'll cover the Fetch API in more detail in Chapter 14, it uses promises at its core. Here's an example using a publicly available API, JSON placeholder, to get a list of posts. Function to fetch posts using Fetch API returns a promise. Function fetch posts. Console log, fetching posts. Return fetch https JSON placeholder .typicode.com/posts limit equals 5. Limit to 5 posts. Function to parse the response as JSON also returns a promise. Function parse response to JSON, response. If response OK. Check if the network request was successful, HTTP status 200 to 299. Throw new error, HTTP error. Status, response status. Return response JSON. Returns a promise that resolves with the parsed JSON. Function to display the posts. Function display posts, posts. Console log, \n fetch posts. If posts length equals 0. Console log, no posts found, return. Posts for each post. Console log title, post title substring 030, ID, posted. Console log, \n. The promise chain in action. Fetch posts. Then parse response to JSON. First, then handles the network response. Then display posts. Second, then handles the parsed JSON data. Catch error equals. Catches any errors in the chain, network, or parsing. Console error, an error occurred during post fetching, error. Finally, equals, always executes regardless of success or failure. Console log, post fetching process completed. Perhaps hide a loading spinner here. Console log, application continues while posts are being fetched. This message will appear before the fetched posts, demonstrating asynchronicity, common pitfalls, and troubleshooting. Forgetting to return promises in a chain. If you don't return a promise from a then handler, the next then in the chain will receive undefined or the return value of the previous then if it's not a promise, leading to incorrect sequencing. Missing catch. Promises that reject without a catch in their chain will result in unhandled promise rejections, which often produce warnings or errors in the console. Always include a catch for proper error handling. Blocking synchronous code inside then. While promises handle the asynchronous part, the code inside your then handlers still execute synchronously. If you have a very long blocking calculation inside a then, it will still block the main thread. Misunderstanding promise all, rejection. Remember promise all is all or nothing. If even one promise in the array rejects, the entire promise all promise rejects immediately. If you need to wait for all promises to settle regardless of success failure, promise all settled, ease 2020 might be a better choice. Summary. Asynchronous JavaScript is a cornerstone of modern web development, allowing your applications to remain responsive while performing long-running operations. You now understand the difference between synchronous and asynchronous code execution, the traditional approach to asynchronicity using callbacks, and the problems leading to callback hell. Promises as a more structured and manageable way to handle asynchronous operations, with their pending, fulfilled, and rejected states. How to create, consume, then, catch, finally, and chain promises to sequence operations. The use cases for promise all, waiting for all, and promise race, waiting for the quickest. Promises represent a significant improvement over raw callbacks for managing asynchronous workflows. However, JavaScript has evolved even further, providing a syntax that makes asynchronous code look and feel almost synchronous. This is the magic of async await, which we'll explore in the next chapter. Further reading, MDN Web Docs, using promises, Google Developers, JavaScript Promises, an introduction highly recommended. Promise all, MDN Web Docs, Promise Race, MDN Web Docs. Chapter 12, Conquering Asynchronicity, Async Await and the Event Loop. In the last chapter, we demystified asynchronous JavaScript and learned how promises provide a powerful and structured way to handle operations that don't complete immediately, helping us avoid callback hell. Promises were a huge leap forward, but JavaScript has evolved further to make asynchronous code even more readable and easier to reason about. This is achieved through the async await syntax. Beyond async await, it's also crucial to understand the underlying mechanism that allows JavaScript to handle asynchronous tasks without blocking, the event loop. This chapter will tie these concepts together, giving you a comprehensive understanding of how JavaScript truly manages its concurrency model. 1. Async await. Making asynchronous code look synchronous. Introduced in EASE 2017, async await is essentially syntactic sugar built on top of promises. It allows you to write asynchronous code that looks and behaves a lot like synchronous code, making complex asynchronous flows much easier to read and debug. The async keyword. The async keyword is placed before a function declaration or expression. An async function always returns a promise. If the function returns a non-promise value, JavaScript automatically wraps it in a resolved promise. If the function throws an error, it returns a rejected promise. Async function myasync function. Return hello from async. This will be wrapped in a resolved promise. Myasync function. Then value equals console log value. Output hello from async. Async function myerrasync function. Throw new error, something went wrong. This will return a rejected promise. Myerror async function. Catch error equals console error, error message. Output something went wrong. The primary purpose of an async function is to allow you to use the await keyword inside it. Await can only be used inside an async function. B. The await keyword. The await keyword can only be used inside an async function. Await pauses the execution of its async function until the promise it's waiting for settles, either resolves or rejects. If the promise resolves, await returns its resolved value. If the promise rejects, await throws an error, which you can catch using a try.catch block. Example: fetching data with async await. Let's revisit our API fetching example from Chapter 11, but this time using async await. A simple promise-based function could be fetch or any other async operation. Functions simulate fetch user, user ID. Console log, async/await simulating fetch for user ID. User id, return new promise, resolve equals. Set timeout equals. If user id equals 1. Resolve id one name, Alice email, alice@example.com, else. Resolve null, or reject for specific cases. 1500. An async function that uses await. Async function get user profile, user ID. Try, console log, starting user profile retrieval. Await pauses here until simulate fetch user, user ID, promise settles. Const user equals await simulate fetch user, user ID. If user, console log user found, user.name email. User email, return user, returns a resolved promise with the user object. Else, console log user with ID userid not found, return null, returns a resolved promise with null. Catch error, console error, error fetching user profile, error message, throw error. propagate the error as a rejected promise. Call the async function and consume its returned promise. Get user profile 1. Then user equals. If user, console log successfully retrieved user, user.name. Else, console log user was null. Catcher equals console error, caught error in catch, message, get user profile 2. This will log user with ID 2 not found. Also demonstrating error handling with an invalid ID. Get user profile invalid. Catch error equals console error, outer catch for invalid ID, message. Console log, execution continues while get user profile is pending. This message will appear immediately, demonstrating non-blocking behavior. Notice how await makes the code look linear, almost like a series of synchronous steps. This significantly improves readability compared to chaining multiple then calls. 2. Error handling with try ... catch. One of the great advantages of async await is that you can use standard try ... catch blocks to handle errors from rejected promises, just as you would with synchronous code. Async function risky operation. Console log, attempting a risky operation. Const random number equals math random. If random number 0.5. Throw new error. Operation failed due to low random number. Return operation successful. Async function perform task. Try. Const result equals await risky operation. If risky operation throws, it's caught here. Console log result. Catch error. Console error, an error occurred. Error message. Perform task, call the async function. Perform task, call it again to see both success and failure. Perform task. This mirrors how errors are handled in many other programming languages, making JavaScript's asynchronous error handling more intuitive. 3. The JavaScript event loop. How asynchronicity works. The async await syntax provides a beautiful abstraction, but beneath it all lies the JavaScript event loop. This mechanism is crucial for understanding how JavaScript can be single-threaded, meaning it executes one command at a time, yet still handle asynchronous operations without blocking. Imagine JavaScript's runtime environment, like the browser or Node.js, having these components: call stack or execution stack. This is where your synchronous JavaScript code is executed. When a function is called, it's pushed onto the stack. When it finishes, it's popped off. JavaScript is single-threaded, so it can only process one task on the call stack at a time. If a task on the call stack takes too long, it literally blocks the thread. Web APIs or Node.js APIs. These are capabilities provided by the runtime environment, not JavaScript itself, that handle asynchronous tasks. Examples include set timeout, set interval, timers, fetch, network requests, DOM events, click, mouse over, etc. File I/O in Node.js. When you call one of these web APIs from your JavaScript code, the browser, or Node.js, takes over and handles the asynchronous operation in the background. Callback queue or message queue. When an asynchronous web API operation completes, e.g., a set timeout timer expires, a fetch request receives data, a button is clicked. Its associated callback function is placed into the callback queue. This queue maintains the order of completed asynchronous tasks. Microtask queue, a higher priority queue that holds all promises then, catch, and finally, callbacks. Microtasks are processed before tasks in the callback queue. Event loop, this is the conductor. It continuously monitors the call stack and the callback queue and microtask queue. If the call stack is empty, meaning no synchronous code is currently running, the event loop takes the first callback from the microtask queue and pushes it onto the call stack for execution. If the microtask queue is empty, it then takes the first callback from the callback queue and pushes it onto the call stack. Illustrative flow. Synchronous code runs and functions are pushed onto the call stack. An asynchronous operation, e.g., set timeout callback 0, is encountered. Set timeout is executed, pushed to stack, then popped. The browser's web API takes over the timer. The call stack continues executing the rest of the synchronous code, e.g., console log, and, after 0 ms, the set timeout callback is done. It gets moved from the web API environment to the callback queue. The event loop checks if the call stack is empty. Once the call stack is empty and the event loop sees a callback in the callback queue, it pushes that callback onto the call stack. The callback function executes. Example diagram simplified mental model. Call stack, event loop, callback queue, web APIs. Why set timeout? 0 doesn't run immediately, console log, A, set timeout, equals console log, B, 0. 0 ms delay. Console log, C, output, ACB. Console log, A, run stack. Set timeout, equals console log, B, 0 is called. The callback equals console log, B, is handed to the web API. The timer starts. The set timeout call pops from stack. Console log, C, runs stack. The call stack is now empty. Meanwhile, the 0 ms timer for set timeout expires. Its callback equals console log, B, is moved to the callback queue. The event loop sees the call stack is empty and the callback queue has a callback. It pushes equals console log, B, from the queue to the stack. Console log, B, runs stack. The key insight is that even with a 0 ms delay, the set timeout callback must wait for the call stack to be empty. This mechanism ensures that JavaScript's single thread is never truly blocked by asynchronous operations. It's just temporarily put aside until the long-running task is ready. Promises and the microtask queue, async await uses this. Promises then, catch, and finally, callbacks are placed into the microtask queue, not the regular callback queue. The event loop prioritizes the microtask queue. This means all tasks in the microtask queue are processed before any tasks in the callback queue. If a microtask generates more microtasks, they are all processed within the same turn of the event loop. Console log script start set timeout equals console log set timeout callback 0 promise resolve then equals console log promise resolved microtask console log script end output script start script end promise resolved microtask wins set timeout callback regular callback waits. This prioritization is why async await functions, which rely on promises, generally feel very responsive. Understanding the event loop helps explain subtle ordering issues and why your UI remains non-blocked even during heavy async operations. Practical application: loading and displaying a user list with progress. Let's combine async await with the concepts of the event loop to simulate loading a list of users, showing a loading indicator, and handling potential errors gracefully. Diositoip HTML. HTML lang equals n. Head. Meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Initial scale equals 1.0. Title async user loader title. Style. Body font family. Sans serif display. Flex. Flex direction. Column align items. Center justify content. Center min height 100 VH, margin 0, background color F4 F4 F4. Container background color, whites padding, 30 px border radius, 8 px box shadow, 04 px 10 px RGBA 0000.1, text align, center. Button padding 10 px 20 px, font size 1M. Background color #007 BFF. Color white border none border radius 5 px cursor pointer transition background color 0.2s button hover background color 56B3 loading indicator margin top 20 px font style italic color 555 display none user list style none padding 0 margin top 20 px text align left max height 300 px overflow Y auto, border 1 px solid DDD, border radius 4 px, padding 10 px. User list padding 8 px 0, border bottom 1 px dashed E. User list last child border bottom, none. Error message color, RGB 220/2060. Font weight, bold margin top, 15 px. Style, head, body, div class equals container. H1 user loader H1. Button ID equals load users btn load users button. Div ID equals loading indicator loading users. Ol ID equals user list slash. Div ID equals error display, class equals error message, div. Script. Const load users btn equals document get element by ID. Load users btn. Const loading indicator equals document get element by ID loading indicator. Const userListive equals document get element by ID, user list. Const error display equals document get element by ID, error display. Function to simulate fetching users from an API. This function returns a promise. Function fetch users from API should fail equals false. Return new promise. Resolve reject equals. Set timeout equals. If should fail. Reject new error, failed to fetch users. Network error, else. Const users equals. id1 name, Alice. id2 name, Bob. id3 name, Charlie. id4 name, Diana. id5 name, Eve. Resolve users. 2000. Simulate network delay. Async function to handle the loading process. Async function load users. 1. Clear previous content and error. userListive.innerHTML. Error display text content equals. Loading indicator style display equals block. Show loading indicator. Load users btn disabled equals true. Disable button during loading. Try. 2. Await the promise from fetch users from API. Execution pauses here until the promise resolves or rejects. Const users equals await fetch users from API false. Change to true to test error handling. 3. If resolved, hide loader and display users. Loading indicator style display equals none. Users for each user equals. Const list item equals document create element, lie. List item text content equals ID, userid name, user.name, user list div append child list item, console log, users loaded successfully. Catch error. 4. If rejected, hide loader and display error. Loading indicator style display equals none, error display text content equals error. Error message, console error, failed to load users, error, finally. 5. Always re-enable but. Load users btn disabled equals false. Console log, user loading process complete. Attach event listener to the button. Load users btn add event listener, click, load users. Optional, load users automatically on page load. Window add event listener, DOM content loaded, load users. Script. Body. HTML. This example elegantly handles the asynchronous operation using async await. The loading indicator is shown and hidden at appropriate times, and errors are caught using try ... catch, making the code flow easy to follow. Crucially, the await keyword ensures that the UI remains responsive, as the browser's main thread is not blocked during the fetch users from API call. Common pitfalls and troubleshooting. Await outside async. Remember, await can only be used inside an async function. If you try to use it in the global scope, outside any function, you'll get a syntax error. Top-level await is an upcoming feature in Ease modules, but not universally available yet. Forgetting async. If you use await inside a function but forget to mark the function async, you'll get a syntax error or a reference error for await if it's an older JS environment. Unhandled rejection. If an awaited promise rejects and you don't wrap the await call in a try ... catch block, the error will bubble up and become an unhandled promise rejection, which can cause your program to crash or lead to unexpected behavior. Always handle potential rejections. Blocking code within a sync function. While await pauses the async function's execution without blocking the main thread, any synchronous code within the async function or anywhere else in your script that takes a long time will still block the main thread. Async await helps manage asynchronous I/O, not synchronous CPU-bound operations. For CPU-bound tasks, you might look into web workers, Chapter 14. Summary: you've now reached the pinnacle of understanding asynchronous JavaScript. The async await syntax provides a clear, concise, and almost synchronous way to write asynchronous code, significantly improving readability and maintainability over promise chains. Standard try ... catch blocks are used for robust error handling in async await functions. You have a foundational understanding of the JavaScript event loop, the ingenious mechanism that allows JavaScript to be single-threaded yet non-blocking, using the call stack, web APIs, callback queue, and microtask queue to manage concurrent operations. With async await in your toolkit, you can tackle almost any asynchronous challenge in modern web development with confidence and clarity. In the next chapter, we'll continue our exploration of advanced functions, diving into concepts like closures and higher-order functions that build on your understanding of scope and functions. Further reading, MDN Web Docs, Async Function. MDN Web Docs, await. Jake Archibald, Tasks, Microtasks, Queues, and Schedules, an in-depth, classic article talk on the event loop. Philip Roberts, What the heck is the event loop anyway? Interactive visualization of the event loop. Chapter 13, Advanced Functions, Closures, Higher-Order Functions, and more. We've covered the basics of functions, including how to define them, pass arguments, and return values. We also briefly touched on arrow functions and their unique binding. Now, it's time to dive into the more powerful and often mind-bending aspects of functions in JavaScript. Functions in JavaScript are first-class citizens, meaning they can be treated like any other value, assigned to variables, passed as arguments, and returned from other functions. This fundamental characteristic unlocks advanced patterns like closures and higher-order functions. This chapter will deepen your understanding of how functions interact with their lexical environment, scope, how they can create powerful abstractions, and how to write more functional, expressive, and optimized JavaScript. 1. Closures. Functions remembering their environment. Closure is one of the most important and powerful concepts in JavaScript, yet it can be initially confusing. In simple terms, a closure is a function that remembers its lexical environment, the scope in which it was declared, even after the outer function has finished executing. This means a closure can still access variables from its parent scope. Think of it like a backpack. When a function is defined, it's not just the code inside the function that's created. It also gets a backpack. Its closure that contains references to all the variables in its surrounding scope. Even if the outer function finishes and its execution context is removed from the call stack, the inner function, the closure, still carries that backpack with the variables it needs. Example, function makeCounter. Let count equals 0. Count is a local variable in makeCounter's scope. Return function. This inner, anonymous function is the closure. Count ++ console log count. Const counter 1 equals makeCounter. Counter 1 now holds the inner function, the closure. Const counter 2 equals makeCounter. Counter 2 holds a separate inner function and separate count variable. Counter 1. Output 1, count in counter 1's closure is updated. Counter 1, output 2. Counter 1, output 3. Counter 2, output 1, count in counter 2's closure starts from 0. Counter 2, output 2. In this example, makeCounter is called twice, creating two separate count variables, one for counter 1, one for counter 2. Each counterX variable holds a reference to its own distinct inner function. The inner function, even though makeCounter has finished executing, still remembers and can modify the count variable from its parent makeCounter scope. This is a closure in action. Practical applications of closures. Private variables encapsulation. Creating private variables that can only be accessed or modified through public methods, mimicking privacy in class-based languages. This is often called the module pattern. Function create person name. Let age equals 0. A private variable conventionally starts with underscore. Return. Get name, return name. Get age, return age. Grow older, age ++. Const Alice equals create person, Alice. Console log Alice get name, output, Alice. Console log Alice get age, output, 0. Alice grow older, Alice grow older. Console log Alice get age, output, 2. Console log Alice age. Undefined cannot directly access age from outside. Function factories. Functions that generate other functions with preconfigured settings. Function create multiplier factor. Return function number. Return number factor. Const double equals create multiplier 2. Double is a function that multiplies by 2. Const triple equals create multiplier 3. Triple is a function that multiplies by 3. Console log double 5, output 10. Console log triple 5, output 15. Event handlers with data. Ensuring event handlers have access to specific data from their creation context. Button ID equals btn1 button 1 button. Button ID equals btn2 button 2 button. Script. Function setup button, button ID message. Document get element by ID button ID. Add event listener click, function. This anonymous function forms a closure over message. Console log message. Setup button btn1, you clicked button 1. Setup button btn, you clicked button 2. Script. 2. Higher order functions, HOFS. Functions acting on functions. A higher order function, HOF, is a function that either takes one or more functions as arguments. These are often called callbacks. Returns a function as its result. We've actually been using HOFS already, especially with array methods like map, filter, reduce, and forEach, which all take a callback function as an argument. Example, map, as a HOF. Const numbers equals 1, 2, 3, 4, 5. Map takes a function and applies it to each element. Const doubled equals numbers map, function, num. This anonymous function is the callback. Return num2. Using an arrow function, more concise. Const tripled equals numbers map, num equals num3, console log doubled, output, 2, 4, 6, 8, 10. Console log tripled, output, 3, 6, 9, 12, 15. Example, a HOF that returns a function, function factory. This is similar to create multiplier we saw in closures, but explicitly defined as a HOF. Function operate on array operation. Operation is a function passed as an argument. Return function R. This HOF returns another function. Return RMap operation. Const square equals num num. Const cube equals num num. Const square array elements equals operate on array square. Returns a function. Const cube array elements equals operate on array cube. Returns a function. Const initial numbers 1, 2, 3. Console log square array elements initial numbers. Output 1, 4, 9. Console log cube array elements initial numbers. Output 1, 8, 27. Currying and partial application. These are advanced functional programming techniques closely related to HOFS and closures. Currying, transforming a function that takes multiple arguments into a sequence of functions, each taking a single argument. Function add a b c. Return a plus b plus c. Console log add 1, 2, 3. Normal call. Curried version. Function curried add a. Return function b. Return function c. Return a plus b plus c. Console log curried add 1, 2, 3. Calling the curried function. Currying allows you to create specialized functions from more general ones. Partial application. Fixing a few arguments of a function and producing another function that accepts the remaining arguments. Function.prototypeBind is a way to achieve partial application. Function multiply, a b. Return a b. Partial application. Create a function that always multiplies by 5. Const multiply by 5 equals multiply bind, null 5. Null is for this context, 5 is the first arg. Console log multiply by 5, 10. Output 50. Console log multiply by 5, 20. Output 100. Both currying and partial application enhance function reusability and expressiveness. 3. Pure functions and side effects. In functional programming paradigms, which JavaScript can lean into, the concept of pure functions is highly valued. A pure function has two main characteristics. It always produces the same output for the same input. It's deterministic. It causes no side effects. A side effect is any change in the program's state that is observable outside the function itself. Examples of side effects. Modifying a global variable. Modifying a function argument if it's an object arrays. Performing I/O operations, logging to console, writing to file, network requests. Mutating the DOM. Example. Impure function modifies global variable. Let total equals 0. Function add to total num. Total plus equals num. Side effect. Modifies total outside its scope. Return total. Console log add to total 5. Output 5. Console log add to total 5. Output 10. Different output for same input due to external state. Pure function. Function add pure a b. Return a plus b. No side effects. Always return same output for same input. Console log add pure 5, 3. Output 8. Console log add pure 5, 3. Output 8 always. Benefits of pure functions. Easier to test. No need to set up complex environments. Just provide input and check output. More predictable. You know exactly what a function will do. Easier to debug. Issues are isolated to the function's inputs and outputs. Cacheable memoization. Because outputs are consistent for inputs, you can cache results. For memoization for performance optimization. Memoization is an optimization technique used to speed up computer programs by caching the results of expensive function calls and returning the cached result when the same inputs occur again. It's only applicable to pure functions. Example: simple memoization for a Fibonacci sequence, recursive and expensive. Simple memoize helper, a higher-order function. Function memoize func. Const cache equals. The closure over cache makes this work. Return function, args, use REST parameter to handle any number of arguments. Const key equals JSON stringify args. Create a unique key for the arguments. If cache key, console log fetching from cache for key, return cache key. Else, console log calculating for key, const result func, args. Use spread operator to pass arguments. Cache key equals result, return result. An expensive pure function, Fibonacci. Function Fibonacci n. If n less or equal 1, return n. Return Fibonacci n1 plus Fibonacci n2. Const memoized Fibonacci equals memoize Fibonacci. Console time, Fib10, console log memoized Fibonacci 10. First time, calculates. Console time end, Fib10. Console time, Fib10 again, console log memoized Fibonacci 10. Second time, fetches from cache much faster. Console time end, Fib10 again, console time, Fib15. Console log memoized Fibonacci 15. Calculates. Console time end, Fib15. Practical application. Creating a customizable logging utility. Let's use closures and HOFS to create a flexible logging utility that can generate different types of loggers, e.g., info, warn, error, and even customize prefixes. Higher order function creates a specific logger function. Function create logger, log level prefix equals. This inner function forms a closure over log level and prefix. Return function message. Const timestamp equals new date to locale time string. Console log $timestamp, log level to uppercase, prefix $message. Create different loggers using the HOF. Const info logger create logger, info, app. Const warn logger equals create logger, warn, warning. Const error logger equals create logger, error, error. Use the created loggers. Info logger, application started successfully. Warn logger, low disk space warning. Error logger, failed to connect to the database. Another example, a custom user logger for a specific user. Function create user logger, username. Const user prefix user. Username, const user error logger equals create logger, error, user prefix. Const user activity logger create logger, activity, user prefix, return. Error, user error logger. Activity, user activity logger. You could also expose general info warn if desired. Const Alice logs equals create user logger, Alice. Alice logs activity, logged in. Alice logs error, failed to upload profile picture. Const Bob logs equals create user logger, Bob. Bob logs activity, viewed product page. This demonstrates how closures allow info logger, warn logger, and error logger to remember their log level and prefix even after create logger has finished executing, making create logger a powerful factory for custom loggers. Common pitfalls and troubleshooting. Closure over variable, not value. If a loop creates closures and the variables they close over change with each iteration, the closures will all refer to the final asterisk value of the variable, not its value at each iteration. Using let or const inside the loop's body creates a new binding for each iteration, correctly solving this. This was a very common bug with var and loops before let const. Problematic with var. For var I equals 0, I3, I++. Set timeout function. Console log I, all will log 3 afterwards. 1000. Correct with let. For let I equals 0, I3, I++. Set timeout function. Console log I, log 0 then 1 then 2. 1000. Performance overhead of memoization. While powerful, memoization adds overhead for managing the cache, stringifying keys, etc. It's only beneficial for functions that are genuinely expensive computationally and called frequently with repetitive inputs. Don't memoize trivial functions. Unintended side effects. When writing functions, especially those used in higher-order functions, be mindful of unintended side effects, particularly when modifying objects or arrays. Where possible, favor pure functions to enhance predictability and testability. Summary. This chapter has pushed your understanding of JavaScript functions to an advanced level. You've mastered closures, understanding how functions can remember their lexical environment, enabling powerful design patterns like private variables and function factories. You now fully grasp higher-order functions, which take functions as arguments or return functions, forming the backbone of functional programming in JavaScript. You've been introduced to currying and partial application for advanced function composition. You understand the importance of pure functions and avoiding side effects for more robust and testable code. You've learned about memoization as an optimization technique for pure functions. These advanced function concepts are critical for writing clean, efficient, and sophisticated JavaScript. They are heavily utilized in popular libraries and frameworks. In the next chapter, we'll shift our focus to how JavaScript integrates with the broader web ecosystem, covering network requests and browser storage. Further reading, MDN Web Docs, Closures, MDN Web Docs, Higher Order Functions. Eric Elliott, Master the JavaScript Interview, What is a Pure Function? Adi Osmani, JavaScript Design Patterns, Understanding the Module Pattern. Chapter 14, Integrating with the World, Web APIs and Browser Storage. Modern web applications are rarely self-contained. They constantly interact with external services and store user-specific data. This capability is powered by web APIs, application programming interfaces, provided by the browser environment and various mechanisms for browser storage. In this chapter, we'll explore how JavaScript extends its reach beyond the local script to fetch data from remote servers using the fundamental fetch API, and how it can persist data locally using web storage, local storage, and session storage. We'll also briefly touch on other useful browser APIs and the important concepts of timers. 1. The Fetch API, making network requests. The Fetch API provides a modern, promise-based interface for making network requests, e.g., retrieving resources from a server. It's the successor to older methods like XML HTTP request, which you might occasionally see in legacy code, but Fetch is preferred. You've already seen Fetch in action in our asynchronous programming chapters. Let's delve deeper into its capabilities. A basic GET request. The simplest fetch call makes a GET request to a specified URL. It returns a promise that resolves to a response object. The response object contains information about the response, like status codes, headers, but not the actual data directly. To get the data, you need to call another method on the response object based on the data type, most commonly JSON for JSON data or text for plain text. Async function get example data. Try const response equals await fetch https json placeholder dot typicode.com/posts/1. Fetch data for post ID 1. If response OK, check if HTTP status is 2xx successful. Throw new error HTTP error status response status. Const data equals await response JSON. Parse the response body as JSON. Console log fetch data. Data, output, fetch data, userid, 1 id, 1 title, body. Catch error, console error, error during fetch, error. Get example data, explanation, fetch URL, starts the network request. Response OK, a Boolean indicating if the HTTP response status code was in the 200 to 299 range. Crucial for error checking. Response status, the HTTP status code, e.g. 200, 404, 500. Response JSON, a method available on the response object that also returns a promise. This promise resolves with the parsed JSON data. If the response isn't JSON, this will throw an error. B post request, sending data. To send data to a server, e.g., creating a new resource, you typically use a post request. You need to specify the HTTP method post, headers, especially content type, to tell the server what format the data is in, e.g., application/JSON, body. The data you want to send, usually JSON stringify, ed. Async function create new post. const post data equals title foo, body bar, userid 1, to try, const response equals await fetch, https JSON placeholder .typicode.com/posts. Method post, specify the method. Headers, content type, application/JSON. Charset equals UTF-8, tell server it's JSON. Body, JSON stringify post data. Convert JS object to JSON string. If response OK, throw new error, HTTP error status. Response status, const data equals await response JSON. Server often returns the created resource. Console log new post created, data output new post created. Title foo body. Bar userid 1 id 101. Catch error. Console error creating post, error. Create new post. Other HTTP methods like PUT for updating, delete for deleting, and patch for partial updates follow a similar pattern, just changing the method parameter. See error handling in fetch. One important thing to remember about fetch is that it only rejects the promise if there's a network error, e.g., no internet connection, DNS lookup failure. It does not reject for HTTP error status codes like 404, not found, or 500, server error. For these, you must manually check response OK or response status. Async function get non-existent post. Try, const response equals await fetch https JSON placeholder .typicode.com/posts /999,999. Invalid ID. If response OK. This is where you handle HTTP errors like 404. Console error post not found. Status, response status. Const error data equals await response JSON. Attempt to parse error message from server. Console error, server message, error data, return, exit function. Const data equals await response JSON. Console log, fetch data, catch error. This catch block handles network errors, e.g., internet disconnected. Console error, network or other critical fetch error, error. Get non-existent post. 2. Web storage API, local storage and session storage. For simple client-side data persistence, browsers provide the web storage API, which allows web applications to store key-value pairs locally within the user's browser. This data persists even after the browser window is closed for local storage or is cleared when the session ends for session storage. Key characteristics. Simple key-value store stores data as strings. You need to JSON stringify, objects arrays before storing and JSON parse them after retrieving. Domain-specific. Data is scoped to the origin, protocol plus hostname plus port, meaning one domain cannot access another domain's local storage. Limited size, typically 5 to 10 MB per domain. Synchronous API, operations block the main thread, not suitable for large data. Local storage, data stored with local storage has no expiration time. It remains available even after the user closes the browser or restarts their computer, until it's explicitly deleted by the web application or the user clears their browser data. Storing data. Local storage set item username, Alice. Local storage set item theme, dark. Storing an object needs stringify. Const user settings equals notifications, true email. alice@example.com. Local storage set item, user settings, JSON stringify user settings, retrieving data. Const stored username equals local storage get item, username. Console log stored username output, Alice. Const retrieve settings equals JSON parse, local storage get item user settings. Console log, retrieved settings, retrieve settings notifications. Output, true. Removing data. Local storage remove item theme, remove a specific item. Local storage clear, remove all items for this domain. To check local storage in your browser, open Developer Tools, Application tab, Local Storage. B. Session storage. Data stored with session storage is cleared when the browser session ends, often when the browser tab or window is closed. It's useful for temporary data needed only for the duration of a user's single visit. The API is identical to local storage, storing data. Session storage set item, last page visited, dashboard, retrieving data. Const page equals session storage get item, last page visited. Console log, last page in session, page output, dashboard. To check session storage, open Developer Tools Application tab Session Storage. Security considerations for web storage. Sensitive data. Never store highly sensitive information, like passwords or credit card numbers, directly in local storage or session storage. This data can be accessed trivially via JavaScript if an XSS, cross-site scripting, vulnerability exists. Not a database, it's a simple key-value store. For complex structured data or large datasets, use more robust solutions like IndexedDB or a backend database. 3 timers. Set timeout and set interval. We've used set timeout to demonstrate asynchronous behavior. These global functions are part of the window object in browsers and allow you to schedule code to run after a delay or repeatedly. A. Set timeout function delay executes a function once after a specified delay in milliseconds. It returns a timeout ID that you can use to cancel the timer. Let timerid equals set timeout equals console log. This message appears after 3 seconds. 3000. You can cancel the timer before it executes. Clear timeout timer ID. This prevents the message from appearing. Console log timer was canceled. This will show. B set interval function delay. Executes a function repeatedly with a fixed delay between each execution. It returns an interval ID that you can use to stop the repetition. Let count equals 0. Const intervalid equals set interval equals count plus plus console log interval message count if count equals 5. Clear interval interval ID. Stop the interval after 5 times. Console log interval stopped. 1000. Repeat every 1 second. Important note, the delay in set timeout and set interval is a minimum delay. The actual execution might be slightly longer, especially if the main JavaScript thread is busy. 4. Other useful browser APIs, brief mention. The browser provides many other powerful APIs for interacting with the user's device and making web applications more capable. You'll encounter these as you build more complex features. Geolocation API, access to the user's geographical location. Web Workers API, run JavaScript in background threads off the main UI thread. Essential for complex, long-running computations that would otherwise block the UI. Canvas API, for drawing graphics, animations, and games using JavaScript. History API, manipulate browser history, e.g., push new states onto the history stack without full-page reloads. Web Speech API, speech recognition and synthesis. Battery Status API, access battery information. This book provides a foundation. Exploring these specialized APIs is your next step for specific application needs. Practical application. Saving user preferences, and fetching dynamic content. Let's imagine a simple web page where a user can choose a theme and load a quote, with the theme being saved to local storage and the quote being fetched from an API. DOCTYP HTML. HTML lang equals n. Head. Meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Initial scale equals 1.0. Title dynamic content and preferences title. Style, body font family. Sans serif display, flex direction, column align items, center justify content, center min height 100 VH, margin 0, transition, background color 0.3s, color 0.3s. Container background color, white padding 30px, border radius 8px, box shadow 04px 10px RGBA 0000.1, text align, center, max width 500px, width 90%, button padding 10px 20px, font size 1em, background color #007BFF, color white, border none, border radius 5px, cursor, pointer, margin 5px, transition, background color 0.2s. Button hover background color 56B3. Theme buttons button active, border 2px solid 28A745. Background color 28A745. Quote display margin top 20px, padding 15px, border 1px-CCC, border radius, 5px min height, 80px display, flex. Align items, center, justify content, center, font style, italic, color, 555. Loading text, color, 888. Slash themes, body light theme background color, F4, F4, F4. Color, 333. Container light theme background color, white. Body dark themes background color, 333, color, F4, F4, F4. Container dark theme, background color, 444, color, F4, F4, F4. Style, head, body class equals light theme. Div class equals container light theme. H1 web integration example H1. Section class equals theme switcher. H3 choose theme slash H3. Button ID equals light theme BTN class equals active light slash button. Button ID equals dark theme BTN dark slash button. Section class equals quote loader, style equals margin top. 30px. H3 random quote slash H3. Div ID equals quote display click, load quote slash div. Button ID equals load quote BTN load quote button. Section, div, script, const body equals document body. Const container equals document query selector. Container. Const light theme BTN equals document get element by ID, light theme BTN. Const dark theme BTN equals document get element by ID dark theme BTN. Const quote display equals document get element by ID, quote display. Const load quote BTN equals document get element by ID, load quote BTN. Const quote API URL equals https api.quotable.io/random. Theme management, local storage. Function to apply theme. Function apply themes theme. Body class name equals theme. Sets class on body. Container class name equals container theme. Sets class on container. Update active button styling. Light theme BTN class list remove active. Dark theme BTN class list remove active. If theme equals light. Light theme BTN class list add active. Else. Dark theme BTN class list add active. Save preference to local storage. Local storage, set item, preferred theme. Load theme from local storage on page load. Document add event listener, DOM content loaded. Equals. Const saved theme equals local storage get item, preferred theme. If saved theme. Apply theme saved theme. Else. Apply theme light, default theme. Event listeners for theme buttons. Light theme BTN add event listener click. Equals apply theme light. Dark theme BTN add event listener click. Equals apply theme dark. Quote loader fetch API. Async function load random quote. Quote display text content equals loading quote. Quote display class list add, loading text. Load quote BTN disabled equals true, disable button while loading. Try. Const response equals await fetch, quote appeal. If response OK. Throw new error failed to fetch quote. Response status text. Const data equals await response JSON. Quote display text content equals data.content, date author. Catch error. Console error, error loading quote, error. Quote display text content equals failed to load quote. Please try again. Quote display dot style dot color equals red. Indicate error visually. Finally, quote display class list remove loading text. Load quote BTN disabled equals false. Re-enable but. Quote display dot style dot color. Reset color. Event listener for load quote but. Load quote BTN add event listener. Click load random quote. Optional. Load a quote automatically on initial page load. Load random quote. Script. Body. HTML. This example brings together local storage to persist the user's preferred theme between visits. Fetch API to dynamically load a random quote from an external service. Async await for clean asynchronous behavior and error handling. DOM manipulation to update the UI, theme classes, quote text, loading state. Event listeners to react to user clicks. Common pitfalls and troubleshooting. CORS issues. When fetching from a different domain than your web page, you might encounter cross-origin resource sharing, CORS, errors. This is a browser security mechanism. The external API server must be configured to allow requests from your domain. For public APIs, this is usually handled, but if you're working with your own backend, you'll need to configure CORE's headers on the server. Network errors versus HTTP errors with fetch. Always remember to check response OK or response status to handle HTTP errors explicitly, as fetch doesn't reject for them. The catch block only handles true network failures or issues during response JSON. JSON parse, errors. If the string you try to JSON parse is not valid JSON, it will throw a syntax error. Always wrap JSON parse calls in try ... catch if the source is untrusted or might be malformed. Synchronous web storage. Be aware that local storage and session storage operations are synchronous. While they are fast for small data, avoid storing very large amounts of data or performing many rapid operations, as this can momentarily block the UI. Summary: you've now expanded your JavaScript skills to interact with the broader web environment. You've mastered the Fetch API for making powerful HTTP requests, GET, POST, etc., to retrieve or send data to external web services, and how to handle their responses and common errors. You understand how to use local storage for persistent client-side data storage and session storage for session-based data, along with their limitations and security considerations. You've refreshed your knowledge of timers, set timeout, set interval, for delaying or repeating code execution. You're aware of the existence of many other browser APIs that empower web applications with rich functionality. With these tools, your web applications can become truly dynamic, responsive, and capable of interacting with a vast ecosystem of data and services. In the final 2 chapters, we'll shift focus to advanced architectural patterns and the tools that help you build robust, scalable, and maintainable JavaScript applications. Further reading: MDN Web Docs, using the Fetch API. MDN Web Docs, Web Storage API. MDN Web Docs, Set Timeout/Set Interval. MDN Web Docs, Web APIs, comprehensive list of browser APIs. Chapter 15, Structuring Your Code, Modules and Design Patterns. As your JavaScript applications grow in size and complexity, simply writing all your code in one giant file becomes unmanageable. It's like building a city with one single, massive building that contains every house, office, and shop chaos. To avoid this, you need effective strategies for organizing your codebase. This chapter will introduce 2 crucial concepts: modularity, breaking your code into independent, reusable pieces, and fundamental JavaScript design patterns, reusable solutions to common programming problems. 1. The need for modularity. Modularity is the practice of breaking down a large program into smaller, self-contained, and independent units called modules. Each module typically focuses on a single, well-defined responsibility. Benefits of modularity: organization, keeps code logically separated and easier to navigate. Reusability. Modules can be reused across different parts of an application or in entirely different projects. Maintainability. Easier to debug and fix issues in isolated modules without affecting the rest of the application. Collaboration. Multiple developers can work on different modules simultaneously without interfering with each other's code. Encapsulation. Reduced global scope pollution. Variables and functions defined within a module, unless explicitly exported, are private to that module, preventing accidental name collisions in the global scope. Historically, JavaScript had various module systems, like CommonJS for Node.js, AMD for browsers. However, EASE 2015 EASE 6 introduced a standardized, native module system that is now the preferred way to organize JavaScript code in both browser and Node.js environments. EASE modules. 2 EASE modules import-export. EASE modules use the import and export keywords to define what parts of a module are made available to other modules. A. Exporting, making code available. There are 2 types of exports: named exports and default exports. A module can have multiple named exports, but only one default export. Named exports. You explicitly name each piece of code you want to export. Example: Math.js. A Math.js. Export const pi equals 3.14159. Export function add, a, b. Return a plus b. Export function subtract, a, b. Return a b. You can also export at the end. Const multiply equals a b equals a b. Export multiply default exports provides a single primary export for the module. It's often used when a module's main purpose is to export one class, function, or object. Example, user.js. User.js. Class user. Constructor name email. This .name equals name. This email equals email. Greet. Console log, hello, my name is this .name. Export default user. Export the user class as the default export. Example, config yes. Config yes. Const app config equals API URL https api.example.com. Timeout 5000. Version 1.0.0. To export default app config. Export the config object as the default export. Be importing using exported code. The import statement is used to bring exported code from other modules into the current file. Importing named exports. You use curly braces to specify which named exports you want to import. The names must match the exported names. Example, main.js using math.js. Main.js. Import pi add subtract from /math.js. Path must be relative or absolute. Console log add 5.3, output 8. Console log subtract 10 pi, output 6.85841. You can also rename named imports using as import add as some numbers from /math.js, console log some numbers 22, output 4. Importing default exports. You can give any name you like to the default import without using curly braces. Example, app.js using user.js and config.js. App.js. Import myUser class from /user.js. MyUser class can be any name you choose. Import app settings from /config.js. App settings can be any name you choose. Const Jane equals new myUser class, Jane Doe, Jane at example.com, Jane greet, output, hello, my name is Jane Doe. Console log app settings API URL, output, https api.example.com. Importing all named exports. You can import all named exports as a single object. Import as math functions from /math.js. Console log math functions add 10.5, output 15. Console log math functions pi, output 3.14159. C. Using ease modules in HTML browser. To tell the browser that a JavaScript file is an ease module, you use type equals module in the script tag. Example, index.html, doc2ip HTML, HTML lang equals n. Head, meta charset equals UTF-8. Meta name equals viewport, content equals, width equals device width. Initial scale equals 1.0. Titleese modules example title. Head, body, script type equals module, src equals app.js/script. App.js will then import user.js and config.js, etc. Body, HTML, when type equals module is used. All scripts are deferred by default, like defer attribute, meaning they won't block HTML parsing, and they are executed in the order they appear in the DOM. Brief mention of CommonJS. For Node.js context, before native ease modules became widely adopted, Node.js primarily used the CommonJS module system, with require for importing and module exports, exports for exporting. You'll still see this in many Node.js projects. Example, CommonJS, my module.js, CommonJS export, function greet name, return hello name. Module exports equals greet. Export the greet function. App.js, CommonJS import, const myGreet equals require, /myModule.js, console log myGreet, world, output, hello world. While ease modules are now natively supported in recent Node.js versions, CommonJS remains prevalent, especially in older projects, and understanding its difference is key to navigating the JavaScript ecosystem. 2 design patterns, reusable solutions to common problems. Beyond modularity, design patterns are generalized, reusable solutions to commonly occurring problems within a given context in software design. They are not specific pieces of code, but rather templates for how to solve problems that can be adapted to various situations. Think of them as blueprints or best practices that experienced developers have found effective. While there are many design patterns, here are a few simple yet foundational ones often applied in JavaScript. A module pattern, revisited with closures. We implicitly touched on the module pattern when discussing closures for creating private variables. Chapter 13. The module pattern leverages closures to achieve encapsulation, allowing you to create private members, variables, functions within a module's scope that are not directly accessible from the outside, while exposing a public interface. Const shopping cart equals function, an IIFE to create a private scope. Let items equals private array. Closure ensures it's only accessible via exposed methods. Function find item, d, private helper function. Return items find, item equals item id equals id. Return public interface, an object of methods. Add item, function item. Const existing equals find item, item ID. If existing quantity equals existing quantity 0, plus item quantity. Else, items push item. Console log $item.name added. Items length. Remove item, function ID. Const index equals items find index. Item equals item id equals id. If index -1, items splice index 1, console log item with ID id removed. Items length. Get total items, function. Return items reduce. Total item equals total plus item quantity 1, 0. Get cart contents, function. Return a copy to prevent external modification of the private items array. Return ... items. Log contents, function. Console log current cart contents, items. As immediately invoked. Usage shopping cart add item, id 1 name. Laptop quantity 1 shopping cart add item, id 2 name. Mouse quantity 1 shopping cart add item, id 1 name. Laptop's quantity 1 adds another laptop. Console log total items in cart. Shopping cart get total items. Output total items in cart 3. Shopping cart log contents. Console log shopping cart dot items. This would be undefined. Items is private. While ease modules offer built-in encapsulation, the module pattern is a similar concept that relies on functions and closures, and it's heavily seen in older JavaScript projects. It's most useful today if you want to create a single, stateful instance that you can expose globally without using ease modules for some reason. B. Singleton pattern. The singleton pattern ensures that a class or object has only one instance, one singleton, and provides a global point of access to that instance. This is useful for things like a single configuration manager, a logging service, or a database connection object. Const settings manager equals function. Let instance, private variable, to hold the single instance. Let settings equals, private settings object. Function init, function to initialize and return the instance. Console log, settings manager initialized. Return, get setting, function key. Return settings key. Set setting, function key value. Settings key equals value, console log setting key, updated to value. Get all settings, function. Return settings. Return a copy. Return, get instance, function. If no instance exists, create one. Instance equals init. Return instance, always return the same instance. Get the first instance. Const settings 1 equals settings manager get instance. Settings 1, set setting. Theme, dark, settings 1. Set setting, notifications, true. Get another instance, it will be the same one. Const settings 2 equals settings manager get instance. Console log settings 2, get setting, theme, output, dark. Console log, settings 1 equals settings 2. Output, true, they are the exact same instance. See factory pattern. The factory pattern provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. In JavaScript, it's typically used to encapsulate the object creation logic into a dedicated function or method. This makes your code more flexible if the type of object to be created varies based on certain conditions. Factory function for creating vehicles. Function create vehicle, type brand model. If type equals car. Return brand, model, doors, 4, drives, function console log $this.brand, this model is driving. Else if type equals motorcycle. Return brand, model, wheels, 2, ride, Function, console log $this.brand, this model is writing. Else, throw new error, unknown vehicle type. Const my car create vehicle, car, Toyota Camry, my car drive, output. Toyota Camry is driving. Const my bike equals create vehicle, motorcycle, Harley Davidson, Iron 883, my bike ride, output. Harley Davidson Iron 883 is riding. Const unknown equals create vehicle, boat, Yamaha, throws error. The client code, where create vehicle is called, doesn't need to know the specific details of how a car or motorcycle object is constructed. It just asks the factory for a vehicle of a certain type. Observer pattern pubsub. The observer pattern, also known as publish subscribe or pubsub, defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. Subject publisher maintains a list of its dependents, observers, and notifies them of state changes. Observer subscriber registers with a subject and is notified of changes. Class event bus. Constructor, this listeners equals, stores event names and their subscribed functions. Subscribe to an event. On event name listener. If this listener's event name. This listener's event name equals. This listener's event name push listener. Console log subscribe to event name with listener.name anonymous function. Unsubscribe from an event. Off event name listener. If this listener's event name return. This listener's event name equals this listener's event name. Filter L equals listener. Console log unsubscribed from event name. Publish emit an event. Emit event name data. If this listener's event name return. Console log emitting event. Event name with data, this listener's event name, for each listener equals listener data. Const event bus equals new event bus. Observers, subscribers. Function logger data. Console log logger, received data. Function updater data. Console log updater, updating UI with data. Subscribe. Event bus on data loaded, logger. Event bus on data loaded, updater. Event bus on user login, logger. Publish events. Event bus emit data loaded. Users, Alice, Bob. Event bus emit, user login, userid, 123 username. Alice, unsubscribe and publish again. Event bus off data loaded, logger. Event bus emit data loaded. Users, Charlie, only updater will receive this. This pattern is fundamental in UI frameworks, state management libraries, and any system where components need to communicate without being tightly coupled. Practical application, modular UI component. Let's create a simple modal dialog as a module, demonstrating encapsulation and reusability. Example, modal.js. Modal.js. Let modal element equals null. Private HTML element reference within the module scope. Function create modal DOM. Private helper function for creating DOM. Const modal equals document create element div. Modal class name equals my custom modal. Modal.innerHTML equals. Div class equals modal content. Span class equals close button and times, /span. Div class equals modal body /div. Div. Document body append child, modal, return modal. Function attach event listeners. Private event listeners setup. Const close btn equals modal element query selector. Close button. Close btn add event listener, click, hide. Uses the public hide function. Modal element add event listener click. Event equals. Close if click outside modal content. If event target equals modal element. Hide. Document add event listener keydone. Event equals. If event key equals escape. And modal element style display equals block. Hide. Public functions for the module. Export function show content HTML. If modal element equals create modal DOM. Attach event listeners. Modal element query selector. Modal body. Inner HTML equals content HTML. Modal element style display equals block. Console log modal shown. Export function hide. If modal element style display equals none. Console log modal hidden. Export a default if you prefer or just named exports. Export default, show, hide, example. App.js using the modal module. Diositoip HTML. HTML lang equals n. Head, meta charset equals UTF-8. Meta name equals viewport, content equals width equals device width, initial scale equals 1.0. Title modular UI demo title. Style, body font family. Sans serif display, flex direction, column align items, center justify content, center min height 100 VH, margin 0. Button padding 10px 20px, font size 1.1 em, background color 4CAF 50, color, white border none border radius, 5px cursor pointer. Button hover background color 45A049. / modal basic styling. My custom modal. Display, none. Hidden by default. Position, fixed, / stay in place. Z-index, 1000, / sit on top. Left, 0 top, 0 width, 100%, / full width. Height, 100%, / full height. Overflow, auto, / enable scroll if needed. Background color, RGBA 0000.4. Black W opacity. Padding top, 60px. Modal content. Background color, #FFF. Margin, 5% auto, / 5% from the top and centered. Padding, 20px. Border, 1px solid 888. Width, 80%. Could be more or less, depending on screen size. Max width, 600px. Position, relative border radius. 8px, box shadow. 05px 15px RGBA 0000.3. Close button. Color AAA float, right font size, 28px font weight, bold cursor pointer. Close button hover. Close button focus. Color black text decoration, none. Modal body margin top, 20px. Text align, left. Style, head, body. Button ID equals, open modal BTN, open awesome modal button. Script type equals module, src equals app.js / script. Body, HTML. Example, app.js, app.js. Import show as show modal from /modal.js. Import named show function and rename it. Const open modal btn equals document get element by ID open modal btn. Open modal btn add event listener click equals const modal content equals h to welcome to the modal /h2. P this content was dynamically loaded into the modal P. You can put any HTML here P. Button on click equals alert, action taken in modal, take action button. Show modal content. Call the imported show modal function. This example shows how modal.js encapsulates its internal DOM manipulation and state modal element. App.js simply imports and uses the show, aliased as show modal and hide functions without needing to know the internal workings of the modal, demonstrating excellent modularity. Common pitfalls and troubleshooting. Relative paths in imports. Remember to always use relative paths, e.g., with ease modules for local files. Missing file extensions, like JS, might work in some build environments but are technically required for direct browser loading. Type equals module. Forgetting type equals module in your script tag will prevent the browser from treating your script as an ease module, leading to import-export syntax errors. Circular dependencies. When module A imports module B and module B imports module A, this creates a circular dependency. While JavaScript ease modules can handle these, it can make code harder to reason about and sometimes lead to unexpected undefined values if not handled carefully. Over-engineering with design patterns. Don't force a design pattern where a simpler solution suffices. Patterns are meant to solve recurring problems, not to be applied for their own sake. Understand the problem before reaching for a pattern. Summary: structuring your JavaScript code effectively is crucial for building maintainable, scalable applications. You now have a strong grasp of the importance of modularity for organizing code. The modern ease module system, import and export for defining clear interfaces between code units. Key design patterns such as module pattern for encapsulation and privacy using closures. Singleton pattern, ensuring a single instance of a class object. Factory pattern, centralizing object creation logic. Observer pattern pub/sub for decoupled communication between components. These tools and concepts will empower you to write more organized, efficient, and resilient JavaScript applications, preparing you for larger and more complex projects. In the final chapter, we'll discuss the broader ecosystem, including testing, performance, and where to go next in your journey to JavaScript mastery. Further reading, MDN Web Docs, JavaScript modules, Refactoring Guru, Design Patterns, excellent resource with good examples for many patterns. Adi Osmani, JavaScript Design Patterns, a classic book on JS patterns. Common JS modules, Node.js documentation. Chapter 16, The Expert's Toolkit, Testing, Performance, and Beyond. You've embarked on an incredible journey. From the fundamental building blocks of JavaScript to advanced concepts like asynchronous programming, modularity, and powerful design patterns, you've built a solid foundation for mastering web development. But the journey doesn't end with understanding the language itself. Becoming a truly proficient JavaScript developer involves utilizing a broader toolkit that ensures your code isn't just functional, but also reliable, efficient, and ready for real-world deployment. In this final chapter, we'll explore crucial aspects of a professional developer's toolkit: software testing, ensuring your code works as expected; performance optimization, making your applications fast and smooth; and a roadmap for continuous learning, because JavaScript and web development never stand still. 1. Software testing, ensuring quality and reliability. Writing code is only half the battle. Ensuring it works correctly is the other, equally important half. Software testing is the process of evaluating software to detect whether the actual results match the expected results and to identify defects. For JavaScript, this primarily involves automated testing. Why test? Confidence. Gives you confidence that your code functions as intended, especially after making changes or adding new features. Prevent regressions. Helps ensure new changes don't break existing functionality. Easier debugging. When a test fails, you know exactly where a problem has been introduced. Design improvement. Writing tests often forces you to write more modular, testable code, leading to better overall design. Documentation. Tests act as living documentation of how your code is supposed to behave. There are various types of software tests, but for JavaScript applications, the most common are unit tests. What they test: individual, isolated units or components of your code, e.g., a single function, a specific class method. How they work: you feed specific inputs to a unit of code and assert that the output or behavior is as expected. Tools. Popular JavaScript testing frameworks include Jest, Mocha, and Chai. Example: conceptual with Jest-like syntax. Imagine a simple calculate tax function in Utils.js. Utils.js. Export function calculate tax, amount tax rate. If amount 0, tax rate 0. Throw new error. Amount and tax rate must be non-negative. Return amount tax rate. In a separate test file, e.g. utils.test.js. Describe calculate tax, equals. Test should calculate tax correctly for positive values, equals. Expect calculate tax 100 0.10 to be 10. Expect calculate tax 250 0.05 to be 12.5. Test should return 0 for 0 amount, equals. Expect calculate tax 0.10 to be 0. Test should throw error for negative input, equals. Expect equals calculate tax minus 100 0.10 to throw. Expect equals calculate tax 100 minus 0.05 to throw. Amount and tax rate must be non-negative. Unit tests are fast and tell you precisely where a problem lies. B. Integration tests. What they test: how multiple units or components interact with each other. They verify that different parts of your system work together correctly, e.g., a component interacting with an API service. Tools often use the same frameworks as unit tests, sometimes with additional libraries for mocking API calls or simulating parts of the system. See end-to-end E2E tests. What they test: simulate real user scenarios by interacting with your application through the browser from start to finish. They cover the entire application stack, from the UI to the backend. Tools. Cypress, Playwright, Selenium WebDriver are popular choices. They spin up a real browser and automate clicks, typing, and assertions about what appears on the screen. Example, conceptual with Cypress-like syntax. Cypress/integration/to-do spec.js. Describe to-do app equals. It should allow adding a new to-do item equals. Sci-visit http localhost:/3000. Visit your app. Sci-get #new to-do input. Type buy groceries enter. Type into input. Sci-get #to-do list lie. Should have length 1. Check item count. Sci-get #to-do list lie. First, should have text. Buy groceries. Check item text. It should allow marking a to-do item as complete equals. Sci-visit http localhost:3000. Sci-get #new to-do input. Type go for a run enter. Sci-get #to-do list lead checkbox. Click a checkbox. Sci-get #to-do list lie. First, should have class completed. Check for class. Automated testing is non-negotiable for serious web development. Start with unit tests for critical logic and add integration E2E tests as your application grows. 2. Performance optimization, making your application fast. A slow or clunky user experience can quickly drive users away. Performance optimization is about making your web applications load quickly, respond smoothly to user interactions, and run efficiently. Browser developer tools. Your browser's dev tools, F12 or right-click inspect, are your best friends here. Performance tab, record runtime performance, CPU usage, frame rates, network activity, and identify bottlenecks. Network tab, analyze network requests, timings, sizes, status codes, and identify slow-loading resources. Memory tab, profile memory usage to detect memory leaks. Lighthouse in Chrome Edge, an automated tool that audits your page for performance, accessibility, SEO, and best practices, giving you actionable recommendations. Key performance techniques, general principles, reduce network requests, minify and bundle, combine and compress your JavaScript and CSS files. Tools like Webpack or Rollup handle this. Image optimization, use appropriate image formats, compress images, and lazy load images. Load only when they are about to be visible. Caching, leverage browser caching and CDN, content delivery network. Optimize JavaScript execution, minimize DOM manipulation. Batch changes to the DOM and avoid frequent, small updates as DOM operations are expensive. Debouncing and throttling. For events that fire frequently, like scroll, resize, input, use debouncing, run once after a pause, or throttling, run at most once per given time period, to limit the number of times your event handler executes. Avoid synchronous blocking operations. Ensure long-running synchronous JavaScript, e.g., complex calculations, doesn't block the main thread. Consider using web workers, Chapter 14, for truly CPU-intensive tasks. Efficient algorithms. Choose appropriate data structures and algorithms, Chapter 8, for performance-critical logic. Critical rendering path. Prioritize loading and rendering content that is immediately visible to the user, above the fold. Defer non-critical CSS and JavaScript. Code splitting. In larger applications, load JavaScript code only when it's needed for a specific part of the application, rather than loading everything up front. Optimizing for performance is an ongoing process, not a one-time fix. Measure, identify bottlenecks, optimize, and then measure again. 3. Beyond the basics. Frameworks, libraries, and ecosystem. As you master vanilla JavaScript, you'll inevitably encounter situations where plain JavaScript, while capable, becomes cumbersome for large, complex applications. This is why a rich ecosystem of frameworks and libraries has emerged to solve common development challenges, provide structure, and boost productivity. Front-end frameworks, React, Angular, Vue.js. These are comprehensive solutions for building complex user interfaces, especially single-page applications, SPAs. They provide component-based architecture. Encourage building UIs from reusable, isolated components. State management, tools to manage the data flow and state of your application. Routing, handle navigation within SPAs without full-page reloads. Tooling, often come with a suite of build tools, development servers, and testing utilities. React, a library developed by Facebook for building user interfaces. Known for its declarative component model and virtual DOM, highly popular, vast ecosystem. Angular, a full-fledged framework developed by Google with a strong opinionated structure, TypeScript integration, and rich features for enterprise-level applications. Vue.js, a progressive framework that is often considered easier to learn than React or Angular, offering flexibility to be used for simple enhancements or full-scale spas. Choosing a framework depends on project requirements, team familiarity, and personal preference. Learn the fundamentals of one of these, and it will significantly enhance your web development capabilities. B. Build tools and package managers, NPM and Yarn, package managers for JavaScript, allowing you to easily install, manage, and share reusable code, packages libraries. They come bundled with Node.js. Webpack Rollup Vite, module bundlers that take your modular JavaScript, CSS, and other assets, resolve their dependencies, and combine them into optimized bundles for deployment, handling tasks like minification, transpilation, converting new JS to older JS for browser compatibility, and code splitting. 4. Where to go next? Continuous learning, community, and building. The world of JavaScript is dynamic and ever-changing. Your mastery is a continuous journey. To stay current and grow as a developer, continuous learning. Keep coding. The best way to learn is by doing. Build projects, big and small. Read documentation. MDN Web Docs is your gold standard. Framework, library, and tool documentation is invaluable. Follow blogs and experts. Many experienced developers share their knowledge through blogs, newsletters, and social media. Online courses and tutorials. Supplement your learning with structured courses. Explore new features. Keep an eye on new ECMAScript features and try them out. Be engaged with the community. GitHub. Explore open source projects, read code, contribute. Stack Overflow. Ask questions, answer others' questions, learn from common problems. Developer communities. Join Discord servers, local meetups, or online forums. Conferences and meetups. Attend to learn about new trends and network. C. Build, build, build. The most effective way to solidify your knowledge is to apply it. Personal projects. Build things that genuinely interest you, even if they seem small. Contribute to open source. Find a project you use and try to fix a bug or add a small feature. Solve problems. Tackle coding challenges on platforms like LeetCode or HackerRank. Create a portfolio. Showcase your projects to potential employers. Conclusion: your JavaScript journey continues. You started this book with a singular goal: to master JavaScript from basics to advanced. You've navigated variables, controls, functions, objects, asynchronous programming, and code structuring. This book has provided a comprehensive map of the JavaScript universe. Remember, the journey of mastery is lifelong. Embrace challenges, stay curious, and keep building. The web awaits your creations, and with your newfound knowledge, you are well equipped to contribute meaningfully to its ever-evolving landscape. Go forth and code.